Hello everyone, my name is Ashish and I welcome you all to module 2 of DevOps. Today we are going to talk about the build tools, the important ones, SCM and CI engine. So today's goal is to learn about Git, to understand what it brings, the power of it, and then we'll be also talking about Jenkins. But today we would not be finishing with the project part, we would be just understanding what Jenkins brings to us. All right, we'll get the machine up and running. We'll configure everything. I'll also talk about a lot of small details which are not present here on the slide. And next class, that would be module 3, we would be describing, not describing rather, but we would be working with Jenkins to fit our project there. All right, I'll get a project, we will create some jobs like we are doing today, but we would be just creating dummy jobs today. We'll not be putting in some sane steps inside of it. It would be just a dummy thing. And in the next class, we would be actually architecting the jobs to form a nice pipeline and executing the real project there. Okay, so let's move ahead with module 2. As it says, it's Git and Jenkins. The next one would be build and test automation. That means Jenkins in detail. Right now, we would be discussing about Git, its architecture, why is it required, what are the features of it. But understand here that all the tools that we are covering, all of them, are actually open source. Okay, they have got a large feature set, enormous features. Okay, a lot of them. We would not be able to cover each and every of it. So I will make a point to take you to a generic level where you can start diversifying yourself. Just for the sake of project, we are diving into the Java part of it. But before this new course curriculum came, we never touched any of this detailed language sections, because every company has got its own requirements and the project keeps on changing, the languages change. Here, since the project part is in Java, it's the more famous language and people tend to use Jenkins more with Java. That's the reason why we are diving into some of the details of how Java is built. All right. Otherwise, I would be talking very generic, very general, and would like to take you from basics to intermediate level where you could start exploring stuff on all by yourself, and you can handle any kind of problems that are there. Because to handle the problems, you need to know the internals of the machine first. Okay, what happens internally? How does it work? That needs to be understood rather than just looking at fancy browser and just clicking the buttons. That works sometimes, but when the real problem strikes you, you will not be able to handle it. Okay, because nothing there are some things that are never handled on screen, right? There needs to be a black and white command line utilities background. So we'll see how to deal with that problems as well. Let's begin. Version control system. So I was talking about VCS yesterday, right? Some also call it as SCM, and we have described it yesterday that okay, VCS and SCM would be helping you to maintain versions of your code. Why in the first place? Why would you need it? Can't Google Docs do that? Or even Dropbox, right? You have a file, you edit it, you put it in the Dropbox, your friend shares the same folder, he gets the updated version of it. Isn't it cool? So he gets it, right? On the Google Docs as well, we can collaborate, we can work. What's the problem with it? So see, the problem is if I made some changes, I can only go back a couple of steps, right? And if I close it, I open it again, the cookies are lost, my Control Z doesn't work anymore. I cannot roll back. I cannot have the complete history of files if I drop them into Dropbox. I cannot figure out why this line was actually created in the first place. Who wrote it? Why did he wrote it? Why did he changed my name to his name? Right? All kind of quarrels. We don't want this to happen. In larger organizations, we don't want people to be blaming one another for the mistakes that they have done or they have not done. And I see it all around the places. Let's say it's a big organization. When I'm saying big, it means that they have got silos in their teams. Okay, that's the general conception. So when we generally visit these kind of organizations and ask people why they are so skeptical about making changes and why do they point fingers, it's all about the blame game. So if something breaks on production, the production guy or ops guy would simply point the finger to the developer that, dude, you gave me the wrong package. I don't know. I followed all the steps that you have given me, and this is what the result is. It's broke. Now you do what you want to do. It's not my problem. Okay. And the developer says, I've tested it on my machine, the exact same package, the same code. I've tested it again because you have blamed it on me. Now it works perfectly fine on my box. It's your headache now. You go and see what's wrong with your box. Okay, so this attitude needs to change. In DevOps, we should never carry the attitude that this is not my problem. That's the reason why we need knowledge from both the ends, dev as well as ops. Okay, it's not that you would be asking developers to do ops job, or you would be asking ops guys to code. There still would be teams, there still would be people belonging to two separate domains, but they would be having their knowledge domain overlapping with the other teams. That's what the end goal of DevOps is, to impart knowledge to people so that they can understand the other side well and behave accordingly, or work out their features and their tool sets according to the other requirements. Okay, so this is not my problem kind of attitude can be solved using DevOps, right culture, plus who did it. If you want to have an audit of that, auditing is very important. Let's say we are making some changes. It could be to the files, it could be to anything else in the infrastructure as well. Slowly down the line, we will learn how to manage infrastructure using our code. Okay, so your SCM also plays a good role there. So I have changed something and I just want to save it. Okay, saving means to make it permanent. Plus, if I would be able to write a comment on it, that why I'm saving this, and it also saves the time when it happened and who did it. That would be really a nice thing, right? And that is permanent with your code. So if someone else gets the code, he would be knowing that this particular person has made this change for so and so reason at this particular time. So nobody has to do any blame games. Everyone knows who did the change, right? Makes sense. And another more powerful thing about version control system is that it automatically handles your conflict resolution. Now, what's conflict resolution? I need a little bit of your imagination here. Let's say we have a file A. So we have file A on the server and my friend wants to change it. So what we do is, let's say something like this. Just hold on. Cool. So this server is having a file and that file name is, we call it as A. Okay. Now there's my friend. I call him as dev1, and there's another friend. I call him as dev2. Okay. These two people wants to collaborate. Collaborate as in they want to share their code. Now the easiest way to share the code would be to have a shared folder between dev1 and dev2 directly. They would be able to see each other's changes. That's fair for just two developers. But in companies, we usually see that there are more people than just two. So what do we do in this case? We put in one common platform, okay? And that platform would be responsible for holding all the code, okay? All the common part. So it would be holding the code for all of the other people. So if dev1 and dev2 goes home, they can rest peacefully and the CEO of the company can still log on to the server and see what's happening. Fair enough. But this is not what conflict resolution is. Conflict resolution means I have a file and I want to make some changes to it. So what happens is dev1 takes the file, dev2 takes the file, okay? So dev1 would be having which file? A, correct? Dev2 would be having which file? A. Now dev1 and dev2 are working on two different functions, okay, on the same file. They are working on two different functions on the same file, which requires to make a function call from some common point maybe. So this common point, someone modifies it and dev1 says that I want to make some changes and I'm going to change this file A to A dash, and then dev2 changes the file A to A double dash. Okay, server still holds the file A. So if someone else, let's call him dev3, wants to check from the server, he would still get the file A. He would not get the file A dash or A double dash, right? Now what happens is dev1 wants to share his code with other people, wants to finalize his changes because he has tested it and he was the first person to commit the changes back. Commit as in push the changes to the closest repository. So here he pushes the changes to the server. He does that. So server asks him a question that, hey dev1, what is your base version? You're sending me a file, but what is the base version of this file? Okay, so dev1 says I made the changes on version A. So server says, okay, it's fine with me. I still have a base version A, so we can match up your changes. So what server does is server modifies A to A dash. There are some internal operations that server does. It also maintains the history. It asks A, tell me the commit message so that I can save it for other people's to check it. Okay. So your changes goes there on server A. Server. The A file changes to A from A to A dash. Okay. Now the base version on the server is A dash. The file has moved. Okay. You cannot move the file backwards. Okay, so the changes are always saved or stacked on top of one another. The revision keeps on increasing. Even if you want to roll back the file to the previous version, of course the changes would be previous, but the revision will still be new. All right, you cannot scrub off. So A changes to A dash, and the server holds that particular copy. There is no conflict so far. The conflict arises when dev2 is not aware of this change. Okay, dev2 doesn't know that the server has got updated copy now. So what dev2 tries to do is, like dev1 did, he also tries to commit the changes back to server. And the server asks him the same question, that what is your base version? What is the base version of the file that you're trying to commit? So dev2 says my base version is A, and server says no, this is not my base version, and my base version has moved from A to A dash. Okay, that's a mismatch. That's a mismatch. Okay, so you cannot overwrite the file. Server doesn't allow you to overwrite the file all by itself. It needs some manual intervention now, and that's where the conflict arises. So what happens? Dev2 then needs to update his data, update the file. So what happens? A now changes to A dash on his computer, okay, on his machine. So he has got A dash, he has got A double dash as two separate files. Okay, that results in conflict, and Git client would tell him, or any version control system that you use, it would tell him that there are now two files which are in conflict. You need to choose one and you need to fix one. Okay, then we fix a file, we ask or ring dev1 and ask dev1 why is that he thinks that he has to change from A to A dash, and dev2 has to change from A to A double dash. So they resolve the conflict manually. They talk over the phone lines or discuss, and then they figure out that okay, we need to change the code to A double dash. So they come to a common conclusion, and now they push the code back. So dev2 would be pushing the code back now after making some changes. So here A dash has changed to A double dash. Again, the same question is asked, that what is the base version of the file? Dev2 says the base version of the file that I'm working on is A dash now, and the server is happy to take in the changes. Now the server is not a bot. It's not intelligent. Okay, its IQ is 0. It doesn't understand why you are coding. It only understands that I need to maintain the revisions of it. Okay, so the tool or the server would send a notification that this is the problem, you are in a conflict, you need to resolve the conflict. Now you need to resolve the conflict as in the developer, and he resolves it manually. It has to be done manually. The server doesn't do it for you. It doesn't do it. Okay. So the question here from Mr. Basu is that why conflict has to be resolved manually? The tool should prompt the change areas. Sure, the tool does tell you that what is the actual conflict, which lines are conflicting, but to resolve them you need to think, you need to do it manually. Okay, it only projects that okay, this is the part which I think is in conflict. It may or may not be even in conflict. Okay, that even has to be thought by you. In most of the cases tool is correct, so the line that it shows is in conflict. You go to the file and you say okay, I want to edit this. There are multiple ways to resolve the conflict. Either you simply choose the other file over the changes that you have done, or you go to the file literally and make the changes, or when the tool tells you that these are the changes, which ones do you want to choose, you choose the either ones between them. But it is always suggested to have a look at the file, at the raw code one more time and then fix it. Okay, that's always a manual thing. Question from Dinesh, that can dev2 lie that my base version is wrong? How the server will behave in this case? Yes, of course you can lie, but the client that you are using for interacting with the server, it is always pre-programmed. Okay, so you'll have to hack it in order to lie, to the server. And if you do, the file would be overwritten on the server end. It's that simple. The file would be overwritten on the server end. So your version control system comes with these benefits. You have got a centralized repository, as in one single server would be there, which would be holding all of your important data plus versions plus history plus the track record. Branching and tagging is one of the important features which is provided. In previous version control systems, I would say, not previous, rather centralized version control system like Subversion, they have got a notion of branching and tagging. When I say notion, it's just like they are fooling you into believing that they can support branching and tagging, but they don't. The actual branching strategies come with distributed version control systems. The more famous one is Git. So we would be using Git to explain what branching and tagging actually means. The learning curve, it says, is small. Yeah, it's small for basic to intermediate level of tasks, but for advanced level, you need to still to Google it out. So yeah, I agree with this. It could be small. Automatic backups to an extent. Okay, not all the version control systems would be having automatic backups for you. And when it says automatic backups, it is actually referring to the service providers out there, something like GitHub or GitLab or Bitbucket. So these people would be having responsibility of keeping your source code safe and secure and backed up on various different machines so that it is never lost. At the same time, they would be charging you some premium amount for that. But if you want to handle it all by yourself in your internal organization, you're not using something like GitHub, you're creating your own setup internally, then you'll have to worry about the backups all by yourself. Okay. Question from Anup, that does server save the previous files somewhere for reference? It doesn't save the file as it is. It saves the change sets. Change sets as in only the part that you have changed. Then when you ask for the previous file, it would play all the changes that happened and it would generate the file for you. Okay, so you can always get the previous file, as in 2 years back. If your version control system is still active since ages, you could roll back the file 2 years back and you see what the file looked like before. Okay, you can do that. So the question is, why Git? Because it's famous, it's used everywhere. And why it is used, why is it famous, what are the features that made it famous? Well, see, these days we are working in global companies, most of us, right? So when we work in global companies or MNCs, these companies have got global teams, distributed teams. And when the teams are distributed, collaboration becomes difficult when using one single server. In the example that I showed you, there was one single server, and the server could be sitting in one location, right? It cannot share multiple regions at once. So either it would be in India or it could be in any other different countries. So if it is in US, people from India would be having very hard time connecting to the server because the latency is more. So response times would be more in that case. And moreover, you always need the connection to be up. You need the bandwidth to be proper. If there is a team of 500 people connecting over a 1 Mbps lease line, it's difficult to maintain the proper connections there. And to have 100 Mbps lease line, company would not shell that amount of money. Okay, so what we could do is we could split it. Okay, we could say, all right, the Indian team would be working on its own servers and US team would be working on its other servers. So that's a benefit. It benefits when you have distributed teams. Plus, there is another bigger concern when there are various different people working on various different products and features going to the same repository. So I have a product, let's say a large website which handles e-commerce plus payments plus distribution plus logistics, a nice front end with all the products and all of stuff. So it has got a lot of features, correct? And I have, let's say, developer strength of 100 people, and all the 100 people are following agile, so they have got their own sprints, they have got their own daily scrum tasks that they would like to work on. Everyone is doing something else. It seems good, but when the changes are reflected back, when they move in, so a person who's working on feature A, let's say it is a big feature and I want to save it slowly, step by step. Okay, so I would not be releasing the complete feature out because I want to trace my own progress, correct? So if you want to trace your own progress, you need to create some save points. That is the reason why we have autosave on Microsoft Word, I guess, right? There is a feature for that. So if you type in a couple of things, it would automatically save your file. It was a very nice feature back then where we when we never had laptops around in the desktops and the power cut was there. So it's good, correct? So in order to commit the changes, it would go to the server, right? If it goes to the server, it would be shared with other people. I don't want it to be shared with other people. I just need to save the logs for my own safety, because I need to roll back. Let's say I screw up my code and I don't know what was the last step I did or what was the last table version of the code. So I need to save it back. So this distributed version control system or any version control system that supports branching and tagging would allow you to work in isolation. All right, I'll show you what working in isolation looks like. Um, so when you commit something back in your own work copy and you create a branch for it, then it would not be shared with the other people. If other people wants to share your code or look at your code, they need to switch to your branch. Okay, most of the work that goes to production is from the master branch. So we never develop directly on the master branch in distributed environments where a lot of work is going on. But it is always desirable to work on the master branch if a larger team is working on a bigger feature and wants to collaborate real time. That's when they share the branch. Okay, so they don't create their own branches. Branching would be more clear when we install Git and work on it literally. Right now, it would be just the imagination thing. Okay, so Git was famous because we are moving towards open source tools. Yeah, most of the people think it's free. Yeah, so that's the reason why they are adopting most of it. And in open source tool development, the teams are global. No one sits in a company and develops open source tool, right? So if they are building it, people are contributing to it over some service providers like GitHub, right? So they would be committing the changes from any part of the globe. At the same time, when they are committing the changes, you need to make sure that there is one single centralized team which is responsible for that particular tool, who decides that whether this change should be a part of the tool or not. If everyone starts to freely commit and release the changes, it would be a mess for open source teams, right? So what they do is they use this Git tool for allowing people to work on their own branches. So people work on their branches and then generate a pull request. So they say that, hey buddy, I have created this particular feature which I think is really cool, or it fixes a couple of bugs for you, and these are my changes. If you are satisfied with these changes, merge it into the master branch. Okay, that's what the pull request means. So these people, the centralized team, would be then reading over the pull requests and then trying to merge it. Okay, if there are any changes required, they would mail the person back that thanks for your contribution, but these are the changes that are required to be done before we would be able to merge your changes. So all these things go on, and Git is very good at that, right? That's the reason why contributing to open source tools requires a good strategic version control system like Git, and people have got used to it, and more they have got used to it, more friendly it seems, and adoption kept on growing. So if you see here, Git wasn't that famous back then. Okay, 2011, if you see, was already an era where open source tools started blooming. It was actually 2008 onwards. So 3 years in line, the adoption kept on increasing, and it is still increasing. So we are talking about Git. There are other tools. Subversion is also a good one. When it comes for bigger teams on a bigger feature, Subversion is the one that you should be using. Okay, you should not be using Git in that case. Git is very good with branching because it manages the changes as change sets. Only the change that you have made is stored, and it is stored as a tree. Okay, it is not stored as stack. So which tool saves the things as stack? It is Subversion. Okay, it stores it in database, and the database is SQLite. If you know that, you must have been working with it. So SQLite is the database that is used by Subversion. Git doesn't use anything. It uses tree-like structure. So tree-like structure is very simple. You have got a node, right? So let's say this is a root node, and then you have got a couple of more nodes. So I am making changes from, let's say I've added the file. So that's my first change. That's node 1. I'll call it node A. Then I made change, my file changed from A to A dash. I would call it as node B. And these changes are not stacked but linked together. These changes are also called as objects. Okay, and the links that I've created are actually called as references. So this is just like a tree in which you create variables. So this is a data structure basically. If you are good at that data structures, you will know what I'm talking of. And there are variables or pointers that point to the end nodes. So there is a pointer called head which always points to the latest node that is being committed back. Okay, I'll take some questions before I move ahead. Question from Siddharth: would you be showing us how to create a localized repository? Because in most cases I would not place my source code on the cloud. Yes, I will show that. I will show you both of the stuff, as in creating it locally as well as how do we create it on the service provider. Question from Siddharth: that will Git create one branch per developer per fix? No, it's totally up to you whether you want to do that or not. So let's say there was file A and my friend wants to commit work on it, but he wants to work on it in isolation because he thinks that he would be spending maybe 2 days, 3 days on it, and other people would be still modifying the file. So he doesn't want to be merging and resolving the conflicts too often. So what he did is he created a branch. Okay, and let's call it as dev1 branch. Cool. So he would be having his own variable head which would be pointing to that dev1 branch. At the same time, there would be one more variable created which would be having name as dev1br. These are just references. Okay, so references will be pointing to a particular node, just like a linked list. You keep on adding the linked list. Okay, you keep adding a node to the linked list, and your head and your tail variables would keep on changing their pointers, right? So consider this to be a linked list, but this is actually a tree. The root node would never change, and it would only keep growing. The number of branches that you create is totally up to you. So it saves a lot of space. It doesn't waste space. It doesn't stack your changes. It only create the branches out. All right. So if you want this file to be regenerated from the branch, then how would it read? It would read like this. It would go back like this. It would trace all the changes right to the root node and then figure out what the file would look like. All right, it doesn't store the exact file. It never stores that. If you want the file to be created back from node B, then it would move like this. In both the cases, the file would look like something different, right? The file on branch would be different than file on the master branch. So when there is no name to the branch, it is given as master. This head here on the right hand side is the master branch's head. Question from Mr. Basudha: what about the comparison with ClearCase and CVS? Well, CVS was previously used even before your Subversion. So they both of them are centralized version control systems, and both of them share very similar kind of architecture. So when it comes to architecture, I would not be dealing with tools like I've told you already. That's the reason why I'm not making clear comparisons between these two tools, but I'm making comparison between a centralized and decentralized kind of tool categories. So your centralized tool category would contain your CVS and Subversion and others, and your distributed would be having tools like Git and Mercurial and so on. Question from Mr. Siddharth: that what is headless Git? Okay, so I'll better answer not this right now. It would only create confusions. Let's first see what Git is. Okay, then I'll come to that. I'll just park this question. Question from Venkat: that can you please provide scenario for branching and tagging? Yes, I'll do that. Question from Dinesh: why we call branch? We can still check out the baseline and keep the working in silo. Yeah, you can do that, but good luck fixing the conflicts later on. Okay, it's a lot problematic. And when you go home, you can, and you blow up your machine, maybe next day you would lose your code. So okay, you cannot work in silo actually. Question from Siddharth: how does the distributed system sync up? Cool. Good question. Let's talk about that. So we have a distributed system. Let me first see if we got something for that. So here the distributed system is something like this. I'm talking very specifically about Git. Okay, so you have got Git server, Git A, and you have got another one, Git B. You may or may not have two servers. You can just have one. Okay, but the benefit of having Git as your version control system is that when you have multiple developers, in case of Subversion, there is only one single server, so it is a client server kind of architecture. There would be multiple clients, one single server which is responsible for holding everything and talking with various different clients. It does not share its data with the clients. Clients only have the actual code. Server would be doing all the versioning and statistics, and also access control. Everything would be done by the servers. So if the server dies, you cannot regenerate the history. It's lost. That's the reason why you need very good backup in case of subversion, centralized version control systems. For distributed, this is not a requirement. What happens is every machine that you have is actually a repository. It is a repository. What is a repository again? A repository is a store which holds all of your code along with its versions, histories, revisions, everything. Authors, time, all the data is kept there along with the actual code. Now this repository comes in two different flavors in Git. One we call it as bare repository. Another one is just a repository. So this repository, which is with the developer guys, is a repository plus there is also a workspace. So developer is able to see the raw code. Okay, and developer 1 and developer 2 both would be having similar kind of repositories with themselves. Now remember the definition of commit that I told you? Committing means to to send your changes to the closest repository. Now for developer 1, what is the closest repository that he has? His own machine, right? So when you commit something in case of Git, it doesn't leave your machine. It goes to the closest repository possible, which is on the same box. So how do I share it? In order to share it, I need to call another command, which is called push, and then it would push it to the server. Server has got its own repository. It's called a bare repo or bare repository. Why is it called bare? Because there is no workspace. So server doesn't need any workspace because no one is going to log on to the server to check the code. Okay, no one wants that. Server should be allowing changes directly on the server side. Okay, so we have bare repo there. Now imagine that your server dies, goes away. You could regenerate the server because you have the history all with yourself, because you are having your own repository, right? Repository means your code plus your history. So you would be having everything with you. That's the reason why people generally don't worry about backups on Git if you're handling it locally, although you would be just having a DR site for it. But it's not a biggie. Even if the machine dies, you don't need to just start running around screaming. That doesn't work. You can just tell your developers to push their code again and the server would be rebuilt. So your backup is already there. Your backup is distributed along with the developers. That's the benefit of it. And since every machine is a repository, Dev 1 can directly push his changes to Dev 2 because Dev 2 is also having its own repository, right? He can choose whatever server he would like to push the data to. In case of subversion, it doesn't work because in subversion, there's just one single server and the clients need to talk to it. All of them. In Git, you can choose. So you have got a version control system that allows you to hop between the different clients. Okay. There's a question from Siddharth that kindly explain how distributed server resolves conflicts among themselves since developers will not be present to resolve it. Okay. See, servers never resolve the conflicts among themselves. They would never. So here, when you talk about Git A and Git B, both of these servers, they're actually connected using hooks. Well, I'm getting into more details right now. I don't think that's relevant here, but just to tell you. So these two servers, Git A and Git B, would never ever result in a conflict because they would be connected with each other via hooks. Whenever there is an incremental change, it is automatically pushed to another server, and both server tries to maintain same revision, same commit as their head commit. Okay, they would never go in conflict ever. That's the reason why we don't need to resolve them. Conflict only arises between Dev 1 and Dev 2. Machines would never do anything all by themselves automatically. And conflict never arises in the repository. It arises on the workspace where you actually have the raw files. Okay. Another question here from Siddharth, that what happens when the machine crashes? It simply crashes, it dies. We get a new machine, the repository is empty, and the code is pushed from the other machines which hold the actual repository. Okay. So along with the code, your history is also pushed. That's the difference between subversion and Git. In subversion, you never push the history along. In case of Git, you also push the history. So when dev1 pushes the code next time, even if Git A, the server doesn't have any code, it would next time have all the code with all the history that is missing. Okay, cool. So that's how Git works internally. And sorry if I took a lot of time of yours, it's not present on slides. So about the workflow, the way it works, Okay, that's a question from Venkat, that will conflict arise between the workspaces? It arises on the workspace, not between the workspaces. Because see, dev1 and dev2 would be having two different workspaces, and the repository has nothing to do with it. So what happens is, whenever you are ready to commit your code, your workspace bundles up everything that has been changed, the new thing, okay, and it forwards it to the closest repository. So the repository holds all your new changes locally. This repository is not aware of how dev2's repository looks like. So what happens? This repository guy then pushes the code. Again, GitHub would ask, what is your base revision and blah 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 blah. If it is checked, your revision goes here on Git A. Then dev2, when it pulls the changes, now dev2 would itself figure out the changes that are coming in. Since dev2 is not a client, dev2 is a server in itself. Okay, Git is a distributed system, so every machine is a server. So dev2 himself knows the changes that are coming in, are they matching my base revision or not? Is my base revision ahead or it is behind? Okay, so in case it is behind, it would simply update itself. In case it is ahead, it would tell you that it is a conflict, you need to fix it. That's how it works. It doesn't arises between the workspace, it's on the workspace. So your changed files which are in conflict would be copied over from Git A to dev2. It would not be committed locally, but it would be just kept on the workspace, and they will ask you to fix it. So yeah. Question from Sai Kumar, that how to resolve if commits are ahead. If the other commits are ahead, you don't need to resolve it, you just need to update it. Okay. Once you update, your own revision would be, your head would be updated automatically. Question from Mr. Gopinath, that are Git A and Git B local repositories specific to developers? No, no, no. Git A and Git B are two different servers, and dev1 and dev2 are the local repositories of those developers themselves. Okay, so these arrows, they are connecting four different machines together, four different machines rather, okay, not folders. These are machines, four different machines, where Git and Git B are servers, dev1 and dev2 are another two servers on which developers are working. Okay, so your own laptop would be acting as a server. You're not connecting anywhere. So let's see how it works, then all of your doubts would be cleared. Let's jump back. Now remember that you have got virtual machines, correct? You must have downloaded it or created it. Either ways, you have a Ubuntu machine on which you can log on, and you can bring in black and white terminal screen. So I'll get my virtual machine up and running, and we'll see how it works. I'd be starting afresh right from the basics. So I got this Ubuntu 32 template which I've created by installing Ubuntu 32-bit Server Edition 14.04 LTS, and I created this virtual machine. Then what I would be doing is, like I told you, I would be shutting it down. I would not be using it. Next time, clone. Okay, that's important. Now, if you are using the OVA, Git is already installed for you, Puppet is already installed for you, Jenkins is installed, Jenkins slave is present, Puppet agent is present. There would be two machines, one would be acting as a slave, another one would be acting as a master, with all the tools on it. In production, we never have that kind of scenario. Okay, so you're free to use anything that you have, anything that you want. If you just want to learn the tool, it is the perfect solution. If you want to set up an infrastructure and see how things work between the machines, then probably you will have to create something like this, the one that you're looking at on screen. A lot of machines that I've created. Okay, it's up to you. So for creating the Git box, like I've done, it's not required that you do this. Okay, it's for the people who are interested in knowing how the actual OVA got created and what happens behind the scenes when you set up a Git server. Because I see a couple of questions about, can we set it up locally? Yeah, you can. So I'm cloning this machine. I'm calling it as Git, reinitialize the MAC address, next clone. Remember to make a full clone. I don't want any dependencies to be present on the parent virtual machines. This will take a couple of seconds, depends on how fast your disk is for copying the data. This is actually copying things from one file to another file. There's a virtual file that is created as a backup of your virtual machine behind. And that's the reason why it is very easy for your cloud providers to move your machines around. They shut down your machine, they take the backup of it. It is just at one single end of your storage. They would copy the backup and start your machine on yet another box, yet another physical hypervisor. So it's easy. Um, Getting to my box, I'm going to start this machine. Okay, so at this point, well, I would go from the very basics, um, although it's not required, but it's good to assume that we are starting from scratch. Okay, as a cloud provider would provide you with uh, any of the virtual machine, that virtual machine would be already connected to the network, plus it would be having its own IP address, which would be shared with you so that you could connect to the machine. So at this level, the black and white screen that you're looking at is the same virtual machine that you would be getting from any cloud provider. Okay, it is bare bone. It is just connected to network, and it has got operating system installed, plus it is having one server installed, which is always a prerequisite for cloud provider VMs. It is called OpenSSH. It allows you to connect to the machine over remote connections. Okay, it is not same as Windows remote desktop. There is no desktop here. It is just allowing you to connect. Cool. So we'll see how to configure it. Although this configuration is done in your OVAs, we will again start it just in case you are curious. So right now it says my name @Ubuntu. Why does it say my name? Because when I installed Ubuntu in my base machine, I've cloned it from the template. Okay, everything is linked. So if you miss a concept, you will keep wondering later on. So do not miss anything. I've installed my Ubuntu in one of the templates in one of the machines. I named it as Ubuntu 32 template. I shut it down. Then I have cloned it. I have started the machine. That machine looks like this. There's username @ the machine name. Machine name is already given. Okay, you don't set it. You just set the username. This is the bare machine. There would be a service running on it. If you want to check the service, you type in sudo service SSH status. It says the SSH is running. All right, so SSH is running. That means you are able to connect to this machine. How do you connect to it? You must be having some IP address granted. You can test it by typing in ifconfig, and there would be some IP address granted to it. If you check, ETH0, ETH1 is already present on this box. ETH0 allows you to connect to internet. ETH1 allows you to connect to other machines, and from host to this machine, the IP address is granted to it. That means I can connect to it. Okay, that would be the case with any cloud provider's virtual machine that you'd be creating. If you are creating the virtual machine all by yourself, in that case there would be just ETH0, which will be allowing you to connect to internet by default if you have not changed any of the settings. Okay, um, but see, we are going to install some services on top of this virtual machine, correct? We are going to install Git, we are going to install Jenkins, might be installing Puppet. So in order to view that page, view Jenkins home screen, you need to connect to this box using a browser. Where is the browser? It's on the host machine, right? Can you connect to this virtual machine from your host machine? Actually not. You need to make some provisions for it. So I'll tell you what I did for making this possible. It would be taken care on the OVA that you would be downloading, but I'll show you crude how to do that. So I'm going to kill this machine for now, because you cannot change the settings when the machine is active. Okay, so you need to shut it down. Either you right click on it and move to settings, or click on the settings button at the top left. Network, and on network tab there are two adapters. Adapter 1 would be configured by default, and it would be set to NAT, network address translation, which will allow you to jump between two different networks, two different categories of networks if you want to be specific. So it acts as router. Basically it allows you to connect to the internet. If there is no router, you will not be able to connect to the internet. You need some address translation to be there. And adapter 2 would be allowing you to connect to your host machine. It is of type host only. Okay, that's how your host machine would be connecting back to your virtual machines. For any of the services that you are installing, this is a must. Otherwise your host machine would not be able to connect. All right, so host only adapter, that's it. If you want to change the boot order, it's in the system just for fun. If you are installing it from the ISO file, storage is something that you would be looking at. You can load your ISO files here in controller IDE. Okay, give it a shot if you are installing your virtual machines from ISO files. So I will be repeating this one more time. Network adapter 1 is set to NAT, adapter 2 is set to host only. That's the only thing that you need to configure. Okay, and then start your machine. So there is a reason why we are using Ubuntu systems. Almost 80% of the servers out there would be using Linux. Okay, 20% of the machines would be using Windows. Good for them. So that's the reason why we want to go with the majority, and majority of the workplaces would be having Linux there. That's the reason we are using this. If you are working with Git, you can install it on Windows as well. Okay, but for completion, I would like to show you how it looks like when you work on black and white screens. That's the reason why I've installed Ubuntu and like got a Ubuntu VM, and inside of that I would be doing all the installations for Git. Okay, so that's the question from Nagendra. So whether your VM is 32-bit or 64-bit doesn't matter. Cool. Sudo su. Okay. Now see, whenever you got a machine, either in your company or from the cloud providers, you would never have a physical console like this. You would never have it, right? The console will be present for you on this VM console only if you are working on server edition. If you have downloaded desktop edition for any reason, you will never get a console. You will get a nice graphical screen for you. So here the black and white screen is present only with the server editions. For desktop guys, I told you not to do that, but just in case you have done it, you could log in inside your desktop machine, okay, and either there are two options then. Either you could open up the terminal from the applications, or you could change your session by typing in control function keys and F1. There are actually 7 terminals which are already present on any Linux machine. So here, see, you're on the box. I have not got any Git servers or any services running on it except for the SSH, like your company would be giving you or the cloud provider would be giving you. Now the next thing would be, I will show you how to connect to this machine. If you are on Ubuntu machines or you are on Mac, you guys are pretty lucky. You could simply type in SSH, then your username, and then the machine IP address, whatever the machine IP address it is, okay, on the host only adapter, like this. It will allow you to connect to this machine over SSH, and you probably know what SSH is because you're already working on Ubuntu and Mac. Okay. For Windows guys, you will have to download and install one more software which is called Putty, P-U-T-T-Y, or PU Terminal. The website is putty.org. It says you can download it here. You could click on that link. Okay, and the first one here, it says download PUTTY for Windows. So once you download it, it looks like this when you open it. It is a nice client that allows you to connect to the servers over SSH. So in my case, the machine's IP address, I could get it from here. Ifconfig is the command that gives you interface configurations. It is 56.234 for me. So I'll try to connect to this machine using my SSH client, which is Putty, and IP address is 192.168.56.234 here. Okay. It's not required to change the appearance, but I would change it just for the sake that it looks bigger on screen. Okay. And that's your terminal. It looks like this. So you log in using your username and your password. That's how you connect to a cloud machine or a VM that your company is providing you. All right. Question from Eric that this would give static IP to each VM, or every time VM boots, the IP gets changed. Most probably, okay, there is no static IP addressing here. Okay, also in cloud it's not. So when you reboot the VM, your MAC address doesn't change. So probably you would be getting the same IP if your IP lease hasn't been expired. Okay, so uh, it would be good just in case of your laptop, but if you're working in production, then there are two options for you. Either you keep the IP address static, or you make sure that you don't use IPs and use DNS instead of IP addresses, and your DNS is always kept updated with very small TTY, TTL, very small TTL values, so that it gets updated whenever the IP address changes pretty frequent. Okay, question from Mahesh that I can connect from Ubuntu to Mac, but not from Mac to Ubuntu, command is same. You should be able to fire SSH. If you are able to type in SSH and it gives you some output, that means it's working. All right. If you can do a telnet from one machine to another one, okay, that means you are able to connect to the port. If you're not able to ping any of the machines, that means your connection is not proper. You need to set up the adapter and your machine should be having an IP address. If you don't have IP address, it wouldn't work. All right. So I'll fix all the bigger problems at the end of the class. If you guys are okay with that, we'll just move with the demonstration right now so that you get the concepts on what has to be done. So the problems like you're not able to ping, or you're not able to send the packets, or you're not able to connect, or connection refused, all of them happens when your machine is not on the network. Okay, that's the prime thing, the first thing. When you create a virtual machine, it needs to be connected to a network. That's the reason why I told you how to set up the adapters. Okay, your ATH0 would be connected by default. It would always be there. For ATH1, you might need to do a little bit of stuff, something like this. So the file is called /etc/network/interfaces. Here, ATH0 would be present by default for you. Okay, and ATH1 is something that I have added. It is the exact copy of ATH0 lines. So what you see on line number 9 and 10 has been copied over on line number 12 and 13. Okay, it is exactly like that, just that ATH0 has changed to ATH1. Guys, please take down the notes if you're not taking it, otherwise you will forget what's happening here. Because these things are not present on slides, and there would be a lot that I would be covering. Once you have done it, you could type in if up eth1 to bring up that interface. If means interface. Okay, interface up. As soon as your eth1 is up, you will get IP address, which will look like this. So you'll have three adapters. One is called loopback adapter. It is always present on your machines. That's the reason why you can connect to your own machine by typing localhost or 127.0.0.1. Does anybody know if we type in 127.0.1.1, where does it connect? And where does it connect when I type in 127.1.2.3? Anyone? 127.1.2.3. We'll see. Of all the network categories, when you say 127, it doesn't fall in any of the categories. It is the loopback address, and the whole network is open for you. So the first octet has to be 127. The remaining three octets can be anything you want. It will still connect back to your machine. Okay, so whatever your IP address is, even if you keep it 127.127.127.127, it will still connect back to your machine. So no doubt in that. ETH1 is the adapter 2 that we have configured. Remember, it is of type host only. So if it is of type host only, it will allow host machines to connect to your virtual machine. If it is not host only, in that case, things wouldn't work. Remember that. IP address has to be taken from your machine, from your virtual machine. Okay. ETH0 will allow you to connect to internet because it is of type NAT, adapter 1, network address translation. All right. Every virtual machine should be able to connect to internet. You could test it out. So it's working. That's how I would be installing any of the packages or updating my repository listings on this box. Now these prerequisites are already taken care of. All right, you don't need to worry about these things. It's already there for you. I'll change the host name just for fun so that I know which machine I'm working on. I can make it persistent by changing it in the file. On Linux systems, everything is a file. All right. So if you want to make things persistent, you can change it inside the file if you want. Next time, if I exit and get back, okay, it should tell you root@git instead of root@ubuntu. That's how you change the host name and make it persistent. Yet another one is hostess, which will have some resolutions made. Hostess is the file that most of you would be aware of. It holds the relationship between the IP address and the host name. By default, it is localhost is already set for you. Okay, you could set any other website you want. I could say www.google.com and connect it to 127. So if someone tries to Google out from my machine, it will not go out. Okay, it will come back in. Cool. So we are here on the machine. We have a plain box with SSH installed. We have logged on to this machine using our SSH client. We have changed the host name If you want to, you could do that. It's connected to internet. All of these prerequisites are already satisfied by a virtual machine provider or a cloud provider. You would already have it. So we're already in a position where we could start installing Git and work on it. Now, since Git operates in distributed way, it uses a secure way of connecting between the machines, and there is nothing more secure than its own native SSH. So Git operates over SSH. Okay, your Subversion doesn't operate over SSH, it operates over HTTP, and it requires a wrapper to work on HTTP because Subversion itself doesn't understand HTTP. So it needs a wrapper called Apache, the most famous one, and Apache helps or assists Subversion in connecting with the other clients. Here with Git, it's not the case. It uses SSH straightforward. SSH is fast, it's more secure. You don't need to worry about authorization because SSH contains authorization all by itself. You could authorize using keys, or you could authorize using usernames and passwords. So we'll do two things. We'll set up a server, we'll also set up a client. Okay. So for setting up the server, see, very first thing that you do is to get things ready for SSH. Okay, so for connecting to this machine, I would not be using the admin user. So I would not be using the user called Ashish here, because that's an admin user, right? It can get to sudo, and everyone, actually, I know the password. I don't want it to be sharing with anyone else. All right, so let's do this. So everyone ready with this? Everything cool as of now, conceptually? So because I would not be repeating these steps now, because every machine would be at the same state when I start, and then we would be installing stuff. Your OVS would be coming with pre-installed Git server, pre-installed clients, and everything would just work out of the box there. I just want to do the things very crude. Fantastic. Let's move ahead. We are going to install Git. Then we will be setting up Git repository. Okay, creating the client, connecting the client back to the server, making sure that SSH is working between these two machines, okay, and making sure that we can clone the repository from the server to the client. That means pull the data from the server to the client. All right, all of these things are going to be there in next 20 minutes. So let's begin. I have this machine. I need to get Git. Is Git installed? It's not. Okay, it says Git is not currently installed. So let's install it. Very first operation that you do is to update your listings. It is enough to do it once a day if your repository listings are not changed manually. If you change them manually, then you will have to do it every time you change the listings. Listing is just the list of servers where the operating system sends the request to fetch the package. Okay. And don't worry about the steps. The command that I'm firing, you would readily get it from any website you want, right? You could simply type in install git, and that's it. It's very, very simple. Don't worry about the steps and the guides, but how do I configure this particular tool? It's all over the internet. You could simply Google it out. And this is not something that you should be remembering. Okay, your head is very much important, and use it for important things, not for remembering these commands. Things would change. Different versions might be having different features, and your commands would change. Okay, when you use them repetitively over a period of time, you tend to remember them automatically. So I've updated my listings, then I'm installing Git. So apt-get install Git. apt-get is a package manager for Ubuntu. Okay, it's called aptitude-get actually. So it says, do you want to continue? Say yes. If you want to install something without human intervention, okay, like we would be doing multiple times using Puppet, right? So in that case, if you want to fire a command, you would be firing a command with non-interactive mode. So you'll say apt-get install -y git. -y means say yes to everything. So it would not ask any interactive console like this. Do you want to continue kind of stuff? It's never asked. Okay. By the time this gets ready, we will get our other machine up and running for ourselves. So I'll start this clone. Clone is yet another machine. How do you create that? You have a template. You again go clone it. You have got a machine. You rename it as client, and you start it. This machine would be having the same settings, same network adapters. There would be two network adapters on this box, which will allow you to connect to this machine from your host box. Plus, this machine would be able to connect to the Git server. Why? Because it is on the same network. Both of these machines would be sharing similar IP address ranges. What is the IP address? I need to get it. It's 122. Okay, so again, get back to your SSH client, try to connect to this machine. Okay, so even if we say that Git is actually a server kind of thing, it's distributed, it doesn't have any client sort of stuff by default. Okay, the package that we install on the server side is exactly the same as the package that we install on the client end. There's no difference. So if you type in apt-get, if you want to install this machine, get this machine as a client, that means a developer machine, you want to create a developer machine out of this, you will simply install Git here as well. Okay, I've already installed it to save some time. So on your server side, how do you figure out which machine I'm working on, since it's all black and white? See, when I'm switching the screens, it says root @client. Okay, so it's the client box for me. @client means the machine name. So this is the client machine. When it says @git, that means I'm working on the server side. Cool, makes sense? So right now we are on the server machine. We need to make sure that we are allowing people to connect to this box. To allow the people connect to this box, I will have to share username and password. Is it a good idea to share the password? No, right? So what's good? It's good to have passwordless authentication. Okay, authentication without the passwords. So we'll be creating keys, public keys and private keys, and then share the keys around. Things would already be configured for you if you are downloading the OVAs, but this should explain a lot of stuff. How would you search for this? You need to search passwordless authentication. Passwordless authentication, that's one word. Okay, authentication is another one. On Ubuntu, it would tell you how to create the keys, how to copy them over to another machine. Good, let's do that. Very first, before creating the keys, I am creating keys specific to a particular user, so I will have to add a user there. I'm going to add a group first. Group add, call it as dev. You could name it anything you want. And then I'll be adding a user called Git to the group that I've just created. And the home directory for that user should be, all the users have got home directories inside /home. You could change the path if you want. By default, Jenkins home directory lies in /var/lib/Jenkins. So it's different. Okay. We'll call it as Git and provide it a shell to fire commands. It's bin bash. The username is Git. Cool. So we have got a user. How do we test whether the user is present or not? You could simply see the contents of the file /etc password. That's a user. It's added. Mind that everything is a file in Ubuntu, so you could look at a file and see what the machine state actually is. Okay, so you've got Git user, you have created a group. Now it's time to create a repository, and then I'll show how to connect to it. Okay, su git, I'm changing my user to Git. That's an important step because we don't want to get into any permissions issue later on. All right, so I'm changing to Git. I'm changing to my home directory. The home directory is /home/git. Remember that. All right, I'm making a repository. I call it as project.git. Okay, cd to your project.git directory, and then you could initialize it in bare format. Init command would create a repository for you. So it's that simple. If you are working on a box, Git is installed. If you want to create a repository, you simply type git space init. That's it. But since this is on the server side, I told you that the repository would be bare. That means there would be no workspace. You will not be able to see the code. Okay. So I have added one option called bare. Even if you don't add bare, it's fine. It works the same way. But people would be able to screw up things here on the server. We don't want that to happen. It says initialized empty git repository. Fine. If you see, there would be a couple of folders automatically created inside this directory. A folder called branches, a folder called hooks, info, objects, references. Now you know what objects and references are, right? Hooks are something like scripts. These scripts are executed on very particular events. I'll talk about that later on when we set it up with Jenkins. Okay. Head is your, again, a variable which points to a particular node or reference. Configurations and description about this repository. That's it. It's simple, right? You created a group, added a user, switched to that user, created the folder, and initialized a repository. Initializing repository is easy. Git bare init. That's all you do. You're done on this machine. You never get back on this machine again. Okay. To allow users to connect to this box, you will have to create the keys and copy them over here. How do you do that? You'll have to create a key all by yourself first. So sh keygen is a command that will create keys for you. Go with the default. Do not add a passphrase because you want to connect to this machine without a password, right? Adding a passphrase will make it more secure, by the way. So I've created the keys. I'll leave it as it is. Done on the server. Now on the client machine, you want to connect to the server. Allow clients to connect to the server side and get the code from there. Is there any code on the server side? Currently, no. But you need to fetch the empty repository in order to make the changes to it. How do we do that? So we'll do one thing. On the client side, very first, we'll try to connect to that box. There are two ways now to connect this machine. Either you connect using IP address or you use a DNS name. Now you could set the DNS name using your DNS provider, whatever you are using for that. I have set up bind for the DNS purposes. If you are using AWS, it would be having Route 53 for that purpose. Your company would be having their own DNS solutions to connect to this machine. Either would work. I'll use the IP address to make it more easier for now. Okay, go back to your client machine. Try to ping this. So that's working, right? Many times, ping would not be allowed in cloud. Okay, so how do you test? You just check whether the machine is reachable on a particular port or not. And one of the ports that you are for sure known is port number 22. So I would say try to connect to this machine on port number 22. It says it's connected. That means machine is up and live. Make sense? Okay, so machine is there and I want to connect to it. I want to rather clone my code from the Git server. So the command is git clone and the server address. So Mahesh is having a question that my client and server has got the same IP address. The problem is you should be updating your MAC address when you create the virtual machines. Okay, when you clone them, you should always update your MAC address. Otherwise, things would screw up. Okay, and I'm not sure why you are getting IP address as 122.1 because .1 is always the adapter IP address. Okay, most probably your machines shouldn't be having .1 as their ending IP address. It should be something else. We'll look into the problems later on. Okay, so how do you connect to this box using the client? You're able to reach it, right? Your packets go to that particular machine. Now, in order to have Git working, you will have sh to work first. By the way, the Git command works in sh fashion. So you would type in git clone, the Git username, @ the machine IP address, okay, and the folder name, actually the repository name for it, project.git. Okay, that's what the command is. Try to connect. It would ask you for a password. Do you know the password yet? No, because we haven't set it. Okay, so let's do one thing. We'll set the password for the Git user. So I'll say password for Git, set it to something that the admin knows. Admin will make sure that no one else knows the password. We go back to the client and we set up the password. But if you set up the password, it will work just once. You will need to tell the developer the password, which I don't want. Okay, so I'll get out of this problem. What I'll do is I will move to the developer machine and then I will ask him that please share me your key. I will copy that over onto the Git server. That's a one-time deal. And when I want to revoke your access, I'll simply delete the key from there. Okay, so let's do that. You now know how to create a key, right? The command is very simple. sh keygen. It would generate the key for you. And now this key we'll be copying over. How do we copy over the key? Let's see. Sh copy id is the command. Sh copy id where to the machine using the Git user. The machine's IP address is this 56.234. Okay, let's copy it. It will ask the password, so we will type the password It's one-time deal. Next time when you try to do SSH on this machine, it would work automatically without a password. Okay, if that works without a password, then your git command would also work without a password. You see, git clone, it should work without any problems. I need to make sure that the folder is clean. Okay, this folder is empty. We'll fire the git command again. All right, it worked. It didn't ask us for the password. If you see, there would be a folder present called project. .git is removed. On the server side, it is mandatory to have .git as an extension to the folders. Now this thing might be new for people who are from Windows. Your folders can have dots and extensions within it. Okay, so we did that. We got a folder called project. If you do cd to that project, you will see hidden folder called git. .git. Okay, all the folders which start with dot, or all the files which start with dot in Linux are hidden by default. So it's hidden. Okay, let me show you what's inside that hidden folder. Might surprise you if you are looking at Git for the very first time. Exactly the same folders that we have seen on the server side, right? So your local repository is stored hidden inside .git. This is how the repository looks like. And on the server side also, we have got the same folders, exactly same folders with the same content. So when you push the changes, these folders are actually synced up on the server side if the base version matches. If not, you will get a conflict on a non-hidden folder side of this, which is called as workspace. So literally this is empty right now. The workspace is empty and your repository is hidden inside of it in folder called .git. Now things start to make sense now. Yesterday we saw a question which talked about .git in Git server. This is what it is. You will not find .git hidden in the server side because there we have created a bare repository. There is no workspace, so we don't need to hide anything there. Okay. Okay. Yeah, guys, getting back. Two machines, client, server. Client and server both have got same softwares, nothing to worry about. Now we are working on how Git works, right? As a life cycle journey of it. So if you see here, there are two blocks. On the left hand side, it's called remote. Another one is a bigger block of three different colors. It's your dev machine, a developer machine. On remote, there's no workspace, so you wouldn't be finding any working files there. Okay, that's only present on the dev side, on your developer machine. That means right hand side. So these are two machines. Left is your server, right hand side block is your client. The very first thing when you do, you will have to get the code from your server side to your client side for the very first time. So what did we do? We cloned it, right? You see the clone operation done, the top. So we have cloned it. It created three things for us: the cloned repository, any branches if there were, and working files. So our repository is empty. There are no branches and there are no files for the very first time, right? Now this is as in the very first root level node, which doesn't have any changes. Now next thing that we want to do is to push the changes back. Now the operations in between, like checkout, fetch, remote, merge, I'll talk about that later. Right now we don't have any of the files to operate, so we would not be able to do that. What I'm going to do is I'm going to try to push the changes back to the server so that my fellow developer, my other colleague, would be able to pull the changes. Make sense? So dev1 is now trying to push and dev2 is trying to pull. We are doing first thing is to clone. Okay, so we have cloned the project already. What was the command? Git clone, right? So git clone was the command that we used for cloning this. If you want to get back to the commands, you could always type in Control R and then search through the commands that we have typed in. Git clone, git @IP address :project.git. That's what we did. So here I'm going to create one file, cd project. I'm going to create one file. Remember that you need to be in your workspace. How do you check? There should be a folder called .git. Similarly with Subversion, there's a hidden folder called .svn. So here I'm going to create one file. How do we create one file? Just add it. I'll call index.html. Okay, and then you insert something. Hello world. In tomorrow's class, sorry, not tomorrow, in the next class, we will see how to interact with GitHub. Okay, in that case, you will not have to worry about creating files like this. There would be already a project that we would be pulling down, making some changes, committing things back. Okay, that project link would also be present in I think today's assignment. If not today, tomorrow's, as in module 3's assignment. So you could check that. It's a full-fledged project on which we could commit and check the changes. So here I've added a file and I want to commit it back. So the commands are very similar in case of Subversion and Git as well. So if I want to add the files, see, before committing, you need to add it. So this image shows you what has to be done. Very first you add it to the staging area. And that makes sense because you can be very choosy about which files do I need to commit. You might be working on 2 features at the same time and you want to commit just one. Okay, Subversion by default doesn't allow that capability. Some advanced clients like Tortoise SVN with Subversion do provide that capability, but Git inbuilt has it. So if there are multiple files, you could literally choose. So I would say git add this particular file, index.html. If you want to add everything down the hierarchy, you could simply do dot. That means everything in the current folder. Okay, git add. If you check the status, it would give you the status. It would tell you that this file is added new. If you want consolidated output, you would say give me a short output. So it would give you a short output with -s parameter. A means added, M means modified, U means updated, G means it is updated with some modification. If it is in conflict, it would show it as it wouldn't show you in the status anyways. And initial commit, it actually means that this is the first commit. There is no commit before it. All right, so this is going to be a first commit. How do you commit it? All the files which are mentioned in the stage area, which you could check using git status command, can be committed. So I'm committing it with a message that this is our first commit. Okay, so it has been committed. Where? It always goes to the local repository. Remember that. It always goes to the first closest repository whenever you commit. So the closest repository here for my workspace is the same repository in which I'm working, right? The local. It goes to the local repository. So this change is not yet present on the remote server. All right. How do we prove it? Let's check. So we have one folder called project. What I'll do is I will clone again. I'll fake that I'm working as dev2 on yet another machine. Okay. We'll call this as test folder. So see, we have got 2 folders, project and test. Project folder is cloned from the server. Test folder is also cloned from the server. Project folder has got a file called index.html and test server has got nothing because server has got nothing. Okay, let's do this now. A good question here from Nirpendra, that do we give the same user access to all the developers? Yes, but what's different? Keys are different. All right. Plus the configuration would be different on every machine. So Git allows you to identify yourself by setting up the configuration like this. Git config, global level configuration. Actually, there are 3 different levels of configuration. Local is local to your repository. Okay, that command is fired when you are inside a repository. If you want global level settings to be set, that means settings for all the repositories that come under your username. Then you set up the configuration like this, global. Okay, otherwise it's local. There is 3rd level of configuration, which is called system. If you are system admin and you want all the users who are working on this computer to be sharing that setting, in that case you would be setting it up as system. So you say system. But as a developer, it always makes sense to have global level configuration which are limited to you and your username. So I would say user.name is okay, give me my name, and user.email is my email. All right. A good question here again from Nirpendra, that there may be permissions issue, or do we create user project wise? Well, see, if you are in a company, then your username is common across the projects. All right. If that is not the case, you're working on a home computer and you're contributing to open source project as well as your company project, then it makes sense to have all the configuration local to the repository, so that different repositories would be having different usernames. Okay. So that's project-wise users rather than user-wise projects. Make sense? So if you see here, we have just committed something in project, right? We have not pushed it. The server doesn't have that file. So I go to project folder and I'm going to push it. So whatever is committed, when you say push, your repository gets synced up with the server repository, of course based on what the base file is. So git push where origin. What is the origin? Origin is the server from where you cloned your repository. You could of course change it if you want. Okay, if you want to check, you can check it as well. Git remote verbose, it will tell you what your origin looks like. Origin for fetching, origin for pushing. So you could pull from one server and push to another one. You could do that in Git. Okay, in Subversion it's not possible. All right, so git push where origin on which branch. By default there is only one branch which is there. I haven't created one, so I would be defaulting to master. It has pushed the code there. Cool. Now your project's changes are on the server side. Now let's see if the test folder gets updated. Right now ls to test, there's nothing. So what I do is I cd to my friend's machine and I'll do one operation called pull. You see here the very first operation on screen, it says pull. When you pull it, then you get all the changes from the remote right in your workspace. Okay, so you do git pull and it will pull the changes back. So there should be a file now called index.html in the current folder. Now see, we have got the files in our local repository. We have seen how to add a file to the stage, how to get it committed from the stage to your local repository, and how to push it from the local repository back, how to pull it from the server side back to your local repository on any other machine. Okay. Now here, okay, one of the questions that I've been asked, the question is from Mr. Sai Kumar. The question is, what is the difference between git upstream and git pull? Well, git pull would be referring to your origin, okay, origin of your current workspace, and git upstream would be referring to the repository from where you have forked your branch. Okay, it will always refer to that. It will not refer to the origin. So that's the basic difference. Another question from Shiv, that what is the difference between clone and pull? Okay, clone would get you everything. Clone means it assumes that you don't even have a repository. Okay, you have a blank slate. You don't have repository, you don't have workspaces, you don't have history. So when you clone it, you get a copy of the repository. All right. When you pull it, you just get the updated change sets. It assumes that you already have the repository, you already have the workspace, but you just want to update it. Okay, so pull means to update stuff. Clone means to get the fresh one. All right. Question from Nagendra, that is there a possibility to pull the older versions of the file, or is it always the latest? It is by default always the head version, that means the latest by default, but you could also pull a specific revision, but you need to know the revision in the first place. Okay, so let's go back to our project folder and see if we could see how things are managed there. Git pull, it's already up to date. Show me the logs. So it tells me that this is the commit ID. It is actually the SHA of the change set that we have created, and it is always unique. All across the world, all across the machines, it is always unique. So your commit ID would be the one which is referring to your exact change. Okay, so when you want to pull something, you could say git pull, and this is particular reference of the commit ID, and it would pull the changes from that particular commit ID. Question from Srinivas, for adding public keys to Git, I heard Gitosis will be used. Could you please show that for adding public keys to Git? I heard Gitosis would be used, right? I wouldn't be using any different tools here, right? It's very simple. I've just created a key, right? I've shown you how to copy it over there. We haven't yet used GitHub, all right? So for using GitHub, I'll show you in the next class. For now, the key that we have created, it looks like this. Search idrsa.pub, okay? So how do you copy it over? You simply copy it over. It's no rocket science. Simply copy this. Okay, either you copy it over using the key, using the command that I've shown you, ssh copy id, or you simply copy it, go to your server side, and on the server machine, put it in a file which is called authorized keys. You see, it is copied over. Either you copy it over manually or you use some utility for that. It's the same thing. Question from Naveen, on server side, can we see the file index.html after pushing? Can you show it? Well, you cannot, because we have created the server side as bare repository, remember? It is for the reason that no one should be able to screw up things here on the server. So if we are here on the server side, if you see here, there is a folder called project.git. If you see the contents of the folders, you will not be able to make any sense out of it. Moreover, there is no file called index.html here. Let's see. Find. You didn't find anything. Make sense? So index.html is not present in the raw format on the server side. It will not be ever be present there. Question from Jagannath: if we want to pull from remote repo but don't want to merge with the local repo, means we can we stash it for later use? Stashing is available for workspace files, okay, which are not committed. So what you could do is you could make some changes and then stash it, and then when you again want to play those changes back without committing, then you could play them. Okay, stash is that operation. Stash doesn't work the way you are asking it for. Question from Naveen: on server side, can we see the file after pushing? No, we cannot. Um, cool. So we'll move ahead with what we were doing, right? So right now we have covered up these operations which are there. A couple of more are there. We'll see. Okay. Um, someone asked about git stash right now. Jagannath, right? So let's see how git stash actually works. It's simple to operate on. Let's say we have some changes, okay, and I don't want to commit those changes. So what do? I go to my machine, I make some changes there. So vim index.html, I'll add some content to this file, new content, save it. Then I'll do git stash. Okay, so what it does is the working directory is actually stored. If you see the file, the changes are removed. Okay, your changes would be removed from your working directory and would be stored somewhere else. Now when you want to play those again, you simply do git stash apply, and it would apply the changes back on your working directory. Okay, so I'll do that again. Git stash, it acts like a stack. So what did it do? It modified the index.html again. Let's see how it looks like. Index.html is back to its original content. But it's not always used. I don't see a very fruitful usage of it other than just stacking the changes and then playing them one by one on even on different branches if you want. If you want to move changes from one branch to another, you could do that. If you just want to differentiate between various different files and then commit them based on your own choice, then Stage is the best place to do that. Okay, instead of playing it using this stack operation of stashing. So right now we have seen a lot about Git. There are a couple of slides which I would be just skipping around. It's distributed. It handles branching. It handles merging. We'll talk about branching and merging, how it works. Your Jenkins would be having some plugins to interact with Git. It also has got plugins by default to interact with Subversion. Okay. We'll see how does it talk to Git and what are the requisites for that. How do we make Jenkins talk to Git with proper user, with proper client, and get the code, also build it. That would be in next class, of course. The commands that we have seen so far: init, add, status, add with a dot, okay, commit message. And when you say commit minus a, that means commit everything without any verification. So it will not add anything to stage. So git add is not required when you simply do -a. So all the files which are modified will automatically be pushed to your local repository without being on stage. So you'll be skipping the stage. You have seen log. You haven't seen working with branches yet. So we'll see how to work with branches. And after that, we'll move on to our next thingy, which is Jenkins. Okay, how do we work with branch? What is a branch actually? I've shown you how the tree-like structure looks like, right? Tree with a root node, it follows one single direction, but when you branch out, it creates yet another node sideways, and the changes can then be applied over that side branch. It is literally a branch, right? In tree terminology, it's called a branch, and the same word has been copied over here to Git. In case of Subversion, it is just a folder copy. So Subversion doesn't work the way Git works. Git works on basis of a data structure called tree. Subversion works like a stash. Okay, so it copies over the changes from one directory to another directory to create a branch. Here in our case, branching would make more sense if we could work in the same folder without worrying about what our fellow developers are doing. So let's see that in action. It becomes very fascinating when we do it at the very first time. So see, this file has got some changes. So if I do git status, I would know that this file has been modified. Okay, M means modified. It has not been added to stage yet. So git status will give me the status of this file. So what I need to do is I'll actually stash it. Okay, and I'm going to create one branch for myself. Right now there is just one branch. So if you type in a command git branch, it will show you that there's just one branch currently, and we don't have multiples. So I'm going to create one git branch and the new branch name. So we'll call it as feature A. So let's say for feature A we want to work in isolation, okay, and not mess up with the master branch because other developers are also working on the master branch. So I'm working in isolation. So this git branch feature A would be sharing the code from master at the base level, right? The point where it branches off. Okay, I don't have that figure right now. We deleted that. Let me see if we can get it. Yeah. So here, your base point, which is node A, will be shared by node B as well as dev1 branch. Okay, so it will be shared by your master branch as well as the feature A branch. Got it? Okay. When I create a feature A, all the code which is on the master will also be present on feature A at node A level. How do I switch the branch? So let's type in git branch first and see how it looks like. So we got feature A and master. Master being shown in green color with a star dot before it. It means it is a selected option. If you want to switch, then you say git checkout the branch name. It tells you that switch to branch feature A. If you type in git branch again, feature A would be highlighted and master will not be. So we have switched the branch. How do we check? Okay, let's make some changes. You know what were the changes on the master branch? It was containing the text called hello world, right? Now I'm going to make some changes in my private branch, which is feature A. Right now this branch is selected feature A. I'm going to change it. Change the content of the file from hello world. We are saying this belongs to feature A branch. Content has changed. All right, cool. So since the content has changed, I would check the status of the file. It says it's modified, so we'll say git add everything. Check the status again. It should be added. It should be green. Okay, now I am committing it back. So git commit. Where would the commit go? To a branch. Okay, git commit. This is a branch commit on feature A. It has been added. How does the file look like now? This belongs to feature A branch. Where am I? I'm on the branch. Okay, let's push the changes back. Git push origin. Where? To a new branch. You see here, it says it's a new branch. It was not present on the server side. Now the server side has got a new branch registered for it. Cool. I'm on the same folder. I've not switched the folder. I'm now going to switch the branch. See what happens. Git checkout master. Switched. What should the index.html contain? Hello world. Okay, that's the power of Git. You work in the same folder, you switch the branch, you get a different content without worrying about switching the folders, without worrying about any content mismatch or overwriting. Your stash command can help you move the content from one branch to another branch because it is not working at the repository level. It simply stacks it up somewhere. You have got two branches right now, both containing two different changes. All right. If you check the log here, you'd be getting just one commit. If you change your branch, so git checkout feature A and then do git log there, you'd be having two commits. Okay. This initial commit to be same, the base is always shared. Okay, if you see this commit, the first one on the master branch, it starts with ECEF, and the previous commit on the branch, it starts with ECEF. Both of them are exactly the same. With a new commit that we have added, this is a master commit on feature A, the new change. All right, how do we merge it? Let's say you have created a branch, now you are trying to merge your branch, which is feature branch. You are done with the changes and you want to merge it back with the master. Okay, if you want to merge it back with the master, there are going to be conflicts. Okay, not always there are conflicts, since we are operating on the same file and the same file has got different content. In that case, it would the server would be confused. Okay, so which file do I choose? Do I choose the file which is on the branch, or do I keep the file which is on the base or on the master side? Okay, it is not able to make some intelligent choices. That's the reason why it asks us to do the merging all by ourselves. So let's see how do we merge it. There's a question here. Question from Naveen that if we are in one branch and stash something and try to switch over to other branch, will Git allow it? Yes, we just did that. I still got the changes stashed. Okay. Question from Srinivas. The question is how to identify which branch we are currently working on. It's simple. Simply type in git branch. It will tell you which branch we are working on. Okay. The branch on which we are working on would be highlighted. Now let's say I want to get the changes from one branch to another branch. So currently I am working on feature A. I am moving to master. Okay. So git checkout master. I am on the master branch. It contains hello world, and I want to merge it with the feature branch. So I'm merging it. Git merge origin feature A. All right, what happened? Index.html got changed. Why didn't it result in conflict? I've already explained it. Why doesn't it result in conflict right now? Can somebody tell me? Okay, there are a couple of guesses, but see, it's not because the lines are different, because if the lines are different, there is definitely going to be a conflict. Someone says, I switched to master. Well, of course, if you want to merge two branches, you need to move to a destination branch and then merge from the source. So that's again not a problem. It's local. No, I've not merged it from local. I've merged it from the origin. That means on the server side. So still, that's not an answer. The clear answer to this is, I've told you already that the changes are always matched against the base. Your master branch is not ahead. It is behind the feature branch. They both share the same base. There is no extra commit which has been added onto top of the master branch yet. Okay. So on image, it looks like this. Node B is not present. It's so simple. So your master branch doesn't contain any node B. It's removed. So when you want to merge your feature A on node A, it is just like copying over feature A here. It doesn't add any complexity. It doesn't add to any conflicts. Does it make sense? Okay. Since there was no commit added on top of master and master was already behind the feature A branch, both shared the same base, same code base. That's the reason why it never had a conflict. If, by the way, if we have committed something on top of the master branch before merging it from the feature branch, there would be a definite conflict in that case. All right. So about the culture that we carry on before doing any pull and push operations, what do we do? How does a normal developer work? Well, he works like this. Very first, he clones for one time in his lifetime when he wants the code for the very first instance. He gets the code, he works on it. When he gets the code, he works on it and he's ready to commit it. He always would first add it to stage. It is not a good practice to add -a in the commit messages. You should not be doing that. Another culture is to have very good commit messages which are self-explanatory, because you are telling it to the world that you are doing this for so and so reason. Okay, it must be descriptive, and it must be descriptive, yet it should be short to understand what's being made. We uh, never follow a practice of committing large bunch of files or enormous number of files at once. We will always make sure that small changes are committed. Okay, if not pushed, at least committed to have that history along. So I've created this function, I've added the code. Okay, and there's a draft. Because the function would be a bigger one or more complex one, I would just create a draft and test it out, create a test case for it, and then commit that base again. Okay, that would be my first commit. Then I add a logic and again test it. That would be my second commit. Instead of finalizing everything and then committing, it would be very easy to screw things up if they are not finalized yet. That's another culture that we follow. Another thing is that before commit, we always make sure that the code is tested. I also explained it right now in an example. Um, you should always test your code before you commit, because that code is going to be pushed, it is going to be shared with your colleagues. Okay, so yeah, and after you commit, you should always make it as a practice to pull the code. Okay, to pull the code from the origin. Sorry, where am I? I'm on the wrong machine. You should always update your working directory first. Okay, that's important, because if you don't update your working directories, there would be a lot of changes that you are not aware of, and your code would be falling on a different line, resulting in a lot of conflicts. To prevent conflicts, merge often. Update your code very often. Updating the code or pull operation will also carry on merge operation on the same branch, which will always force you to update your code and fix conflicts as and when they arrive. Okay, it will prevent a lot of headaches later on. So that was an answer to a question from Srinivas, that I believe there should be a culture of following some basic checks before committing push or pull. Can you please explain? Question from Eric, that you mentioned during a commit, history is also merged with the master. Is that log you mean? Yes. If you check the log, I'm on master branch, but I got a commit which is from feature branch here. Okay, so code and history both are synced up with your remote server. Whenever you do a push, both are synced there. Question from Nirpendra, that can we also have git slave? See, every git instance that you run is actually a server in itself. When you call out for git slave, I understand that you just want a machine to be holding all the data backups. Yes, we can have it. And I've already explained that during the discussion when we were having git A and git B servers, both were syncing their data using some hooks. Okay, so you could call either one of them as slave, but there is no notion of slave here since it is a distributed architecture. Another question here from Hema. Yes, Hema.
Yeah, I want to ask one question, Ashish, that would we have different keys for feature A and feature B?
Different keys as in different commit IDs, you mean?
IDs, yeah.
See, when the changes are moved from one
See,
branch
it
to
is
another one.
what I understand, that whenever we are committing a new commit, new changes, so it is changing, right? It is storing into a new commit, right?
Yep.
So I want to know that is there any unique key for feature A and feature B also? I mean, under which it is committing again and again and
Yeah, see, whenever you commit, there is always a unique ID that is generated. There's always a unique one. Okay. For feature A and feature B, when you create two branches, there's always going to be unique again. Is
okay.
it what you mean?
And let's say if I want to revert back,
Mm-hmm.
yeah, if I let's say if I want to revert back my changes, okay, I have
Mm-hmm.
performed two commits, okay, on feature
Mm-hmm.
A. I have written the code two times and I have committed it, okay. Now I want to revert back the changes
Mm-hmm.
to let's say my commit was on A. Now I have committed two times. Now it is on A2, A1 and A2. Okay, and I want to revert back to A1. How can I
Mm-hmm.
do that?
You can do that by typing git checkout with some parameters, which will also accept your parameters,
Hello,
mentioning the commit ID.
am I audible?
Yep, you are. So, uh,
Hello.
cool. So the question that him asked was, how do we check out the previous revision or fall back to the working directory when we mess up with some changes? How do we revert it? So git checkout is actually a command which can also switch the branches. At the same time, it will fall back to the latest head revision of the code which is in your working repository. So how do we do this? Let's say I mess up with this file, index.html. All right, I change it, and now I forgot what was actually written there. Okay, and the changes that I've made are also not proper, so I think that it would be a good idea to fall back to the base version. So currently the file contains some random changes. How do we revert it? Git checkout which file you want to check out, and it would fall back to the previous version of it. Okay, you can also mention the revision number, the previous revision number of the file. If it is not the head revision, if you want to revert back to previous 2 revisions or 3 revisions, you could find the commit ID by typing git log. Okay, get that log ID from there and then type it as a parameter to the checkout command. It would also work. There is another question here from Eric, that git pull versus git pull origin master versus git pull origin something. What's the difference? Well, when you say git pull, it always pulls from the origin. Okay, and the origin is set to whatever the remote values are. So if you type in git remote minus v, it would tell you where it would be fetching or pulling by default. All right, next one, when I'm specifically mentioning git pull origin master, I want to be very specific about the master branch. If I don't mention it, it would still pull it from origin master, but it is always a good idea to be specific about things. When I push it for the very first time, master branch is not available. That's the reason why I want to be specific. I pass it to origin master because master branch is not available, and I specifically mention please create a master branch for me if it is not there. When there are multiple branches, then you need to be specific about which branch you are pushing things to. All right, that's what the difference is. Question from Jagannath, that if you want to revert to commit 4 out of total commit 8, so all the commits that at 5, 6, 7, 8 will be deleted. No, they will not be deleted. I told you one thing, right? It is never reverted back. So whenever you're trying to revert, it creates yet another commit. So there would be commit number 9 created, which will look exactly same as commit number 4. Does it make sense to you? So 5, 6, 7, 8 will be there. There would be a commit 9 which is created, which will be same as commit number 4 when you revert back. So basically your file would be reverted back, but the commits and the log history will not be reverted. It will still be there. You will let people know that you have done it for a reason.
Yeah, hi Ashish, able to hear me?
Yes.
Okay, it's related to the similar question what Hema asked, wherein she had 2 commits done and she want to go back to the previous version. So it's very simple over there. But in reality, if you look at, there'll be multiple versions within the same branch. And looking at the commit unique ID, it's going to be difficult for me to understand what was the previous versions, or maybe I want to go back to the 3rd or 4th version from the current 10th version. So is there a way to understand or know what are the versionings or how many versions you have for a file, or any way graphically I can pull out, or some command which will tell me I can directly go back to the 5th version of the file or 3rd version of the file?
Yeah, that's one of the biggest reason why people would like GitHub and not just Git black and white screen. So if you go to GitHub and move to any of the projects, let's sign in. I'll show you one of the projects. We'll move to some open source project, search for something. So you're in the repository, you would be able to see the workspace, and when you go to the commits, you should be able to see the commits there as well. You see here, the IDs are actually abbreviated, but you are able to see the history. So that's the reason why you need a detailed commit log, which will have proper messages to it so that you could figure out what your revision would look like. So let's say I wanted to go to this particular commit. Okay. So I'll get the ID from here. It's difficult to find IDs from black and white screen. What you could do is you could fire your command git log and then pipe it through grep, and then grep your comment, which will give you your commit ID as well. So you'll have to go through that, or use GitHub or GitLab. GitLab is used, can be used internally as well. It is open source and it's free for implementing it inside your company. So most of the people do use GitLab internally.
Okay. Yep. Thank you.
You're welcome. Question from Naveen, that how to revert the changes which are already pushed to server? We cannot. It's the same thing, the same question that Jagannath asked. what do? So we commit a new change which appears to be like the one which is reverted and then commit it back and push it back to server. So things only can move forward, they cannot move in history. Okay, time cannot be rolled back. Question from Dinesh, we can go back to specific version by looking into revision details. Yes, that's what I explained. Thanks for that. How can we see the difference between various different versions, right? That's a good one. There is a command called diff. Okay, so if I make some changes, you can also pass some revisions to it if you want. I'm going to make some changes. Okay, some more parameters to it. You can match it between two different revisions of the same file or the same directory. It will give you the changes. The exact diff file can also be exported if you want to. Cool. So we'll get back to GitHub later on, maybe in the next class, and we'll see how does it interact with Jenkins. So for now, I'll move ahead. We'll get into details of more working with Git, how to install the plugins and interact with Jenkins, okay, in the next sessions. For now, in the next half an hour, we'll see how to get Jenkins up and running. Okay, there's one more question here. Question from Jagannath that if there are 10 commits in branch 1 and I would want only commit 6 and commit 7 to be merged with branch 2, is it possible? Yes, it's possible. You can mention that as revision when you merge the code. You remember I typed in the command git merge and then origin/master. You could also specify the revision ID --rev. That particular revision should be merged back. You could do that. Git is very flexible about choosing things because it is a tree-like structure. You could specifically mention which node you want to merge with which other node. If you don't specify it, it is always going to be the head node, the last one. Okay, cool. So for your understanding of Git, just remember that it is a data structure called tree, and anything that you can do on tree, you can do on Git for all of your answers. Okay, let's go through these questions first. If your local machine crashes, changes are not pushed to remote directory repository, can you restore the changes made in the local repository? That's a long question, right? Let's make it short. So you have some changes locally and your machine dies. All right. So can you restore the changes back? Okay. So see, there are two fronts to this question. When the machine crashes, there could be two meanings. Either it crashed just once or it is totally out of order. So you'll have to restore it or you'll have to scrub it off and reinstall it. So if that's the case, in that case, the answer is false. Okay. You cannot. But if you can get back your repository, you can always push it back to the remote server. In that case, the answer would be true. Question second, what does the pull command do? You already know what it does, right? It fetches the complete repository, or it fetches the merge changes from the remote repository to working directory, or it fetches only the changes and explicitly runs the merge command to update your working directory. It doesn't explicitly runs the merge command, but it merges it internally. Okay, so the answer would be B for second. There's your answer. All right. Question number 3. Now here, Git branch is actually better than the previous one. Subversion only acts on folders. Okay, it literally copies the folders along if you are branching it out. But in case of Git, it is allowing you to put your commits to any other node that you can. Okay, when you create a branch, you're actually splitting out the nodes. So here, like I said, you'd be able to do any operation that you could do on trees, and that would give you a hint on what this question's answer would be. And question number 4, which is when do you use the checkout command? Of course, when you want to switch the branches or you want to revert the changes. All right, so let's see what the answers are here. Okay, cool. So what we have done until now is only the first phase of the CI/CD pipeline on the dev side. Okay, SCM, the first trigger point. But how do we use this trigger point? We need something to keep an eye on it, something to always make a check that someone has committed something there and I need to trigger the build pipeline. All right, so we'll see how that is done. So we need a server, an engine which will be continuously on, and the tool that we are going to use is Jenkins. Okay, what Jenkins would do for us, it will keep an eye on Git for now. Okay, I'll get into details of Jenkins, of what it does, what are the feature sets, how do we use it, what are the plugins and all that stuff later on. For now, on your OVA VM, you will be having Jenkins already running there. Okay, how do you check that? You will go to your machine and you could type sudo service Jenkins status. If it is up, it will tell you. If it is not up, it will also tell you that it's not. If it is not installed, it would tell you that it is unrecognized service. It's not present. Let's install it. For installing any of the standard packages or services, Google is the one that will help you out. Let's do this. So let's say I'm a beginner. I'm just fresh out of college. I don't know how to install Jenkins. So I'll do something like this: install Jenkins. And I know that different operating systems would be having different ways of installing stuff. So I'll say install Jenkins on Ubuntu. If I want to be very specific, I'll just say 14.04. Okay, like this. So go to the official page. Always remember, official websites are true source of information. Do not pick it from any other first hit or advertised section. Don't do that. So I'm choosing the link, which is jenkinsci.org. Okay. The reason I wanted to show you this, because I want you to trust these official documents. And at the first time, you would not be able to remember the lines that I've highlighted. Okay, neither I do right now because I don't make it a point to remember things like this. So what I do is I simply copy over these 4 lines and hit them on my machine. Jenkins would be installed. As simple as that. Or you copy over and paste one by one. What it actually does is it would be adding the key for you, which will be authorizing your machine against the public repositories. Which public repository? Then you add the repository listing, a customized one. And what's about the repository listing I told you? It is the server destination where your machine would be connecting in order to search the package. All right. Which package? Jenkins. How does the machine know about it? It will get the updated listings by typing the command apt get update. That's the 4-step process. If you want to break it down, it's just 2. Updating the repository listings and adding the package. How do you do that? I'll get a fresh machine. Why am I getting a fresh one? Again, the same reason. On OVA, you would be having everything spoon-feeded. In production systems, you will always have a new machine for a new service. Make sense? So what I did, I saved some time. I don't want to waste time in downloading the files and showing you the download process moving from 0 to 100%. So what I did was I installed Jenkins beforehand. I made the machine ready, but I'll pretend that it's not installed. Okay, I'll repeat the steps again. How is this machine created again? Clone it. 56.119 is the IP address. I'm connecting to this machine. Of course, I can fire commands directly. 192.168.56.119. That's my box. Sudo su, because I don't want to type sudo again and again. Service Jenkins status. So it is running here. What you do is you fire commands like this. First, it will add the key. It will authorize your machine. Then you jump back to your browsers. See, to copy things over in your virtual machine directly on your desktop requires sharing of clipboards. Okay, if you are more interested in doing that, there is a setting in VirtualBox to share your clipboard. Since I have not shared my clipboard and I prefer using the clients for connecting the machine, I could directly use my putty client to copy and paste things there. That was second command. You will have to do this for Docker as well, for Ansible as well. Any server, any tool which is not available as part of public repository on your operating system has to go through these steps. Update and then apt-get install Jenkins. Once you install Jenkins, you will find a couple of things on your machine. I'll show you what happens in the background when you install Jenkins. Again, don't worry about the steps, right? Google it out. There's just 4 lines which will help you to have Jenkins on your machine. No worries here. What you should worry about rather is the internals which are not present on any other websites. So installing Jenkins does like this. So it will be downloading Jenkins and then installing it. I'll leave it for now because I already have that installed on my computer. So see what happens. Very first thing, it adds a new user. So if you open up the file, etc password, you will see one more line added. Jenkins, it would be there. Okay, and the home directory for Jenkins, var lib Jenkins, like I've told you before. It's not /home, okay? It's var lib Jenkins. So let's move to that directory. You will see some files, some folders already created at this level. The important ones for you, jobs, would be containing all the jobs that we are going to create. You remember the stages in the pipeline? Testing, deploying, building, okay? All those stages, we are going to create those stages, and those stages we'll be calling as jobs. All right. All the job configurations goes in the folder called jobs. I'll get into details when we create the jobs there. Logs would be holding logs for Jenkins. Nodes would be holding different slave machines for Jenkins. Why do we need a slave machine? Building can be a CPU extensive process, if not memory extensive, intensive. So in that case, your master machine would not be able to build a lot of jobs at once. Okay, that's one of the reasons why you want distributed system. Another reason could be that you want to build the code on CentOS where your Jenkins machine is on Ubuntu, or you want to build the code for Windows but Jenkins machine is on Ubuntu. Okay, for that, building code on Ubuntu wouldn't make sense. You will need a machine which runs Windows or runs CentOS as their base operating system. So what you could do is you could create a VM or get a machine, run Jenkins client on it. Jenkins client can be executed on a number of different um, operating systems wherever you can find Java. Okay, so nodes would be holding data for those machines. Data isn't just the connection requirements. The actual data is just the code would be holded on those machines only. It would not be here. I told you before in yesterday's class that Jenkins is just a framework. Okay, it doesn't provide features all by its own. It gets the features from the plugins. So by default, there would be some standard plugins which are already available, and some would be installed by you. So plugins folder would be holding all of the plugins that are currently installed. And the ones which are not installed would be present in the updates folder, which would be lined up after you choose them and restart your Jenkins. They would be added again. Then there is a secrets folder which would be holding your keys, users folder which would be holding your users that you are going to create during authorization phase. Workspace would be holding your actual code, not the configuration. Jobs folder holds the configuration. Workspace holds the actual code that you're working on. Okay, so if you want to take a backup, you can take a backup of everything that this folder has, varlib Jenkins contains, except the workspace folder, because that can be regenerated. Okay, so you can delete everything, whatever is in the workspace, and then take a backup of everything which is outside of it. Zip it, keep it somewhere. Jenkins does not use any database. It relies on the XML files for storing its configuration. Okay, so for the people who think a different way, you can really screw up things if you mess up with the XML files. All right, or if someone is not giving you access to the front end, you're a Jenkins admin, you could go to the back end and modify the changes and save things. One such use case would be when you lock yourself out of Jenkins. Let's say you are trying out it, and you have accidentally set up security without creating your own user account. That means Jenkins doesn't have your user data, you are not able to log in. What you could do is you could change some configuration files. The default configuration is present in configuration file called config.xml. You will find config.xml files all over the place in different folders at various different levels. At different levels, the same file mean different things. Okay, and it would be having different settings. At the global level, at the root level, right now, it is a global level file that handles the global level settings of Jenkins. Job level settings would be placed in jobs folder in proper jobs subfolders in a file called config.xml again. Okay, this is how a config.xml would look like, the global one. Okay, I'll not go into details because it's very generic. You can change stuff from the console and you could go back and search it here. Let's say for security that I was talking, on line number 7, it says use security. It's turned to true. Okay, you could turn it off false. Make sense? Yeah. And then restart Jenkins. How do you restart? There are three ways of restarting it. You could restart it from here. Service, Jenkins, restart. It is the crudest way possible. Don't do it. If you do it, all of your jobs that are running will be halted, would be killed, and your system would be in unpredictable state. Your developers will rush back to you asking what happened. Don't do this unless and until you're really sure about what you're doing and there is no other job executing on your machine. Okay. Another way is to go back to your browser and then ask Jenkins to be restarted from there. So since Jenkins service is running right now, by default the Jenkins server runs on port number 8080, which you can change. All right, the file name is Jenkins. It is in the folder called /etc/default. Line number 57 holds the port number. Of course, you can change it to anything you want. That's the file name. /etc/default/Jenkins. For users who are new to Linux, any of the packages which need default settings would be placed in the folder /etc/default. That's the general one. And for the specific settings, they would always be present in a folder called /etc/the package name. But for Jenkins, it is not present. For other packages, it would be present. So let's see how Jenkins look like. I'll go back to my browser on my host machine. Remember the IP address, and also that we have set up the network adapter 2 as host only, so that my host machine can be is able to connect to the virtual machines. IP address is, that is 119. All right, 192.168.119.8080. Remember the port. It is 8080. You hit it, you will get the Jenkins up and running. Is it that I logged out myself? If that's the case, I can also revert back. Okay, Jenkins looks like this. So I've built a couple of things already. Don't worry about what the things look like. I've pre-built it for you just to have a look and feel of what it looks like when it is populated. Okay. Next class we will be scrubbing off everything and starting afresh with all the stages that we need to build. So this Jenkins is actually built in Java. It runs as a service. So on your machine, on your admin box, that means on a Jenkins machine in the background, you will see a service which is running in Java. PS grep Java. Okay. So if you see here, the name of the service is Jenkins. Okay. So there are a couple of threads which are running there. It was first meant for Java projects, then the plugins came along and we started to use it for other projects as well. There are various different ways in which we create a job. So yeah, I wanted to tell you how to restart it, right? /restart. That's the second way of restarting things. Here, if you hit yes, it would restart it from here. Of course, you'll have a clear view of what is running and what not, because the pipes here on the left hand side bottom, the ones that I have highlighted, would be showing how many jobs are currently executing. All right, so these executors are nothing but pipes, lanes. Okay, if you are on a 4-lane highway, how many cars can go in parallel at once? Only 4. So only 4 jobs can be executed in parallel in this kind of situation where I have 4 executors. Okay, slave 1 would not be present by default. That's the machine that I was talking of, the distributed architecture. Okay, your Windows or CentOS boxes that you want to add it for distributing the load, you could add it there. I'll show you how to do that. Don't worry about the configurations yet. Okay, here where I'm saying restart, yes, I'm restarting the whole machine without worrying about the jobs, but I can still keep an eye on what's happening there. The best way to restart Jenkins is through manage Jenkins. You jump to the admin console and there's an option for shutting it down. Okay, prepare for shutdown. So you click on it. It says it's going to shut down, and it will shut down only when there is no builds are running. Okay, so you see, it's going to shut down when no builds are running. So currently there is no build running, so it is safe to shut it down. Okay, that's the best way to do it. Another way Jenkins can be I'll cancel it for now. Another way Jenkins can be shut down, it's very similar to the shutdown process that I've mentioned, but it can also be done via plugins. Okay, there's an option for restarting it. So when you install a plugin, there are 4 different options basically. Let me show it to you on slides. I'll skip through a couple of them. There are other containers in market as well. Just like Git, we have GitLab, which would be having its own internal CI. GitHub also provides one. Travis CI is another one which is paid. TeamCity is again paid. The free versions are very limited. Okay, so don't trust them with the free versions. Jenkins is totally free with all of its plugins, and that's maybe one of the reasons why it is more famous amongst the community. Jenkins also provides integration with most of the other tools out there. You name a tool and there would be a plugin for it to integrate it with Jenkins. Okay, that's why it has been a de facto standard in industry for continuous integration services, and we are using it. So what does it do for you? Allows you to create stages. What can you do in a stage? You can run commands, you can build your code, you can test it. Okay, building, running, it's just one thing. It boils down to only one thing. What is it? Running commands. Okay, so Jenkins can run shell and window batch commands as well, directly out of box. Or you use a plugin which will do the same thing but on your behalf. If you want to run Maven commands, you install a Maven plugin, and it will fire command which is mvn space whatever the goals are on your behalf, of course. Okay. Okay, creating of jobs. I told you that in many ways we can create it. All right. I'll come back to this page. Plugin categorization. Okay, let's see. Creation of stages has mainly to be done about has to do with what kind of project you are building. So here in Jenkins, if you want to create a job, click on the new item on the top left. So we'll come to a page which looks like this. Okay, I'll do it again. You go back to your Jenkins dashboard. On the Jenkins dashboard, you'll be able to see a button which is on top left, which says new item. You click on it. Okay, it will get you to a page which looks like the one which was shown on the slide. There are multiple options out there. Okay, we're going to choose the one which is Maven project. So freestyle allows you to do anything and everything that your plugins would provide. The number of features that Jenkins would give you is directly proportional to the number of plugins that you have. If you don't have a plugin, the feature will not be present. It will not be shown on screen. Okay, so freestyle will give you all the possibilities that your plugins would provide you. If you want a Maven project, all the other functions would be hidden. Just the Maven part would be projected along. So you can do all the other kind of projects just using the freestyle project. That's what I basically meant to say. Even the Maven projects can be built using a freestyle, pipeline can be built using a freestyle, external jobs can be executed using a freestyle, because freestyle gives you total capabilities. If you want to specialize in one of the category, then you can choose the other ones. What does it mean? Maven would be specialized for running Maven builds on Java projects. Pipeline would be allowing you to programmatically create a pipeline. The different stages that we are talking of, all these jobs would be programmatically binded together. So let's say there are 4 jobs created, A, B, C, D, and you want to create a pipeline. That means you want to stage the jobs one after another one. How do you stage it? Either you go to the jobs and tell the job that, hey B, I want you to run after A. You hook it. I'll tell you how to hook it. There is a possibility of doing it using post-build actions and also pre-build executions. So you tell C that I want you to be running after B, and D, you tell D that I want to run you after C. So when A executes and finishes with a success, B automatically starts. When B finishes with a success, C automatically takes over. And when C finishes with a success, D takes over. You can do it manually, or you could create a pipeline job. If you know Groovy, that's the program language that Jenkins uses internally. If you know Groovy, you could do this. External jobs is when you want to execute some process outside Jenkins, and you need to trigger some jobs outside Jenkins and not want Jenkins to run it. All right, so it's like having 2 versions of Jenkins, one here, one somewhere else, and you want to trigger that external job using this Jenkins master, you could do that. Not always useful. Multi-configuration project is when you want to literally run code on various different versions of operating system. These kind of jobs are used by security teams to test their code against different machine types or different devices. Okay. People who create antivirus would be using these jobs much often, or people creating firmwares would be doing this. Multi-configuration project is again another one, which is talking about multi-configuration. The folder is just a hierarchy. You created some jobs and you want to classify them. Okay, so that's the folder. It's not a job. It's actually a plugin feature which is called folder plugin on Jenkins. The new version of Jenkins that we are using, this is Jenkins version 2.0 plus. Jenkins after versions 1.67 has gone drastic changes. Okay, if you're using version 1.67 and older, these things will not be present there, and version 2.0 later on is completely different thing. So GitHub integration and multi-branch pipeline, which again talks to Git, has already been built in here. I'll not talk about GitHub and multi-branch pipeline much. It just integrates with GitHub, and whenever some project changes, there's a new branch created or there's a new commit, you don't need to set up the polling here. The polling that we are going to set, we are going to do it a crude way. Okay, so I'm going to build things using freestyle project. Even if on slides it mentions to be a Maven project, I'll show things how to I'll show how to do things using freestyle so that you can classify your requirements according to other things that are mentioned here on screen. So for now we haven't done anything yet. Let's move back to slides and I'll just talk about Jenkins a little more. So in today's class we are not working on Jenkins yet. Okay, so don't worry about that. About the jobs, your different jobs can have different build steps. So talking about a stage, just building can have a couple of more steps inside of it. So building the code would need creation of directories, getting the code, um, creating some more target directories, sanitizing the code, running some tests, then building it, packaging it. So these steps means firing different level of commands or different targets for Maven. Okay, so here they have specified just 4 targets on the left hand side bottom. You could see. Don't get overwhelmed by the image and the way it looks like. It's very simple. 3 columns are 3 stages, and every stage have got a couple of more steps inside of it. Okay, we will classify them when we create the jobs in next class. So don't worry about the stuff right now. 3 stages: building, testing, deploying. We will again break it down because in our case we are going to deal with far more stages than what they are mentioned here on the slides. There are a lot of plugins. Let's see, literally a lot of them. You could Google it out if you want. On Jenkins front, you could go to Manage Jenkins, and in Manage Jenkins page you would see one called Manage Plugins. You click here. There are 4 different categories. Updates, that means any of the plugins that needs updation would be here. Available would be the plugins that are not installed but are available with Jenkins. Installed, of course, would be having all the installed plugins on your computer on Jenkins. And advanced would be having some advanced capabilities of getting plugins from the server which are not controlled by Jenkins itself. Okay, you can also have some search capabilities there. So let's say I want to install one plugin, something like this. I want to install a plugin that talks with Git. Okay, so I've already installed that plugin, so I'll do it one more time if you want. There are a lot of them. Okay, so if your friend says that I work with this plugin, it doesn't mean that you should also be working with that. There would be a lot of them. Choose the one which suits your requirement. So I'm choosing Git parameter plugin. By the way, if you want to work with Git and just initiate Git polling, that plugin is by default pre-installed in version 2.0. It was not installed in version 1.67 earlier. All right, that plugin is called Git plugin, Git space plugin, plugin. I'm installing this plugin just to show you how it looks like. Click on install without restart, and this is the 4th way where you can restart Jenkins by clicking on this checkbox. Okay, and click on it. Let's see if it restarts Jenkins for us. It's restarting. You can also enable auto refresh, by the way. It's top left. Okay, there's a small section where you could enable it so that you don't have to auto refresh it again. Cool. So that plugin has been installed now, and if you could check the update center again, sorry, I moved away from it. You could check the update center again in manage plugins. Oh, it's slow. Okay, and installed, you should have that plugin installed. It was called Git, right? You could search it here right on the top, Git parameter plugin. See, it's installed. So that's about the ecosystem. The more you work with it, the more you'll know about it. The default config.xml file that I talked about, you can configure it from here. The first two options, configure system and configure global security. These two options reflect in config.xml at the top level. Okay, the executors that you see on the left hand side, 4 executors that I was talking of, which is a 4-lane system for you. By default there would be just 2. It is always a good idea to have number of executors which are less than twice the number of CPU cores on your computer. If your computer is having 4-core CPU, then it is a good idea to keep number of executors to an optimal level of 8, not more than that. If you keep it 4, it's awesome. If you keep less than that, even it's wonderful. But in that case, it would not be able to make use of multiprocessing. Okay, Jenkins can make use of it. So make use of it here. You can change the number of executors the way I'm changing it. At the middle of screen, it's written 4. Change it to 2. Save it. You will have the changes reflected right away. Okay. There are multiple settings. We'll talk about settings, creating jobs, creating stages, showing the build pipeline, changing the views, creating security, adding the users, all in the next sessions. I would like to take just a couple of minutes of your time. It would be 5 more minutes to talk about what the pipeline would look like. Although we already know it, just for sake of completion. Now see, pipeline as we see it, we need to push the code horizontally through various different stages. If you see the scenario 2, testing, releasing, deploying to test, then redeploy to pre-production and deploy to production. We never push the code directly to production out. We never do that. We always deploy it internally, as I have talked about in a last class as well. Okay. But in our case, we're going to make it a little bit more diversified. So we are going to unit test things first, run some acceptance test on it, also called as user acceptance test or UATs. We'll check how much the code coverage is. You remember me talking about code coverage, that if your code coverage is more than 95%, 97%, you could be pretty sure that your things wouldn't break on production. If it is 50% and you push code directly to production, it is bound to be broken, right? Because it is not completely tested. And we cannot rely on manual testing a lot when we are automating stuff. So that's third section. Deploying to integration for different modules, integrating them, running some tests on the complete system at once, making sure that the baselines of operation are actually valid, regression test. Okay, the basic features are working, if not all. UAT testing and performance testing is again done. Okay, alerts and reports are generated after that, and then it is deployed to production. Okay, so after every stage, when we do a deployment, that stage has to go through some rigorous testing before we promote the code. And we will see this delivery type pipeline to be deployed and to be created. So we'll create a lot of jobs. We'll specify them in different folders. We'll categorize them. So working with Jenkins, hold on for now. Okay, you can just play along with stuff, install it, see, explore it all by yourself. You have got ample amount of time. Next 5 days, you're free to work with Git and Jenkins, and then come back and we'll see how to work with stuff. If you want to learn about how to build Java, go through the pom.xml file. I'll talk about this file in next class in detail. Although we are not going to be Java experts anyway sooner, but this would make sense to understand what the file looks like. Okay, cool. For the quick recap of what we did, can Jenkins handle two different kind of jobs with 2 different kinds of parameters? Yes, we can, right? It is a multi-configuration type. And we can also have the things done using the initial type. Okay, so we can use parameterized builds for that. Jenkins can send you notifications. It can email you. It can IM you. It can Skype you. Okay, it can send you an email if you want. It can ping some other jobs of the failure or success as well. All right, so the notifications can work. If you want to pull the changes, you need to check. Right, I told you that this engine, this server would be responsible for keeping an eye on Jenkins. Keeping an eye on Git server. So when I say keeping an eye, that means you continuously keep checking. All right, whether this has received a new change or not. Again, after 1 minute, I'll again check. That recurring operation is called polling. All right. So that brings us to the end of this module. About the pond.xml file and working with Jenkins, don't worry about it. We are going to spend a good amount of 3 hours of time in the next class. And I think it should be more than enough for covering each and every aspect of it. Cool. So the next class, if we see that, it's about Jenkins management, talking about test automation, how to secure it, how to create the users, how to create the jobs, how to categorize them, how to send a notification, to create the jobs and create various different stages, rather create a pipeline for your code. We will see how to do that. Couple of jobs would be dummy jobs. Let's say how to deploy stuff. So what I'll do is I'll deploy stuff using some core commands, crude commands. And next time when we learn about configuration management, we will ping Puppet to do things on our behalf. Okay, so things will keep improving as we learn them, and we will again fall back to Git. We'll again fall back on SCM concepts and DevOps concepts as we move ahead. All right. So thank you so much for being with me. I really appreciate your time here and your patience. Um, and I know that I've just taken one break, so you must be exhausted. If you have got any questions, feel free to ask them. Type in your chat boxes or raise your hands. I'm still here for as much time as you want. First question from Eric. Yes, Eric, you have a query?
Hello?
All right. Yes, I can hear you.
See?
Yes. You
Hello?
have a question? Yes, I can hear
Yeah.
you.
Yeah, the thing is this, I need to know the VM machine that you're cloning out. You are using a generic Ubuntu image, or is it like you have downloaded it from the portal only? Uh, because there is no image given particular of the version that you told to us on the portal.
Yeah. So don't worry about the version. It needs to be Ubuntu. I'm using very generic solutions. Okay. I'm not using the OVA as of now. The reason for that is I wanted to show you everything crude from scratch, but the OVA is built using the same technique. They have pre-installed softwares for you. So if you scroll down after installing VM, there it says that where to get the OVA from, right? For other people who are new to this, I'm just opening up this PDF for you. This is it. All right. To answer your question, I'm using the crude one. I'm not using the OVA.
Okay.
Yep. Thanks. Another question. I'm going alphabetically, guys. So if you have to wait for just long, sorry for that. Question here from Anup. Yes, Anup.
Yeah, so I have installed the master and slave in VM. I'm not able to see the images like Git Jenkins the way it was shown in your desktop. So
Yeah.
if I show you my screen, then it will be easier to understand the things. So that at least
See,
my setup will be there that I can start the work.
exactly. So you have used OVA, I guess, right? It
Yeah,
will
yeah, correct.
create two machines for you. One would be master, another one would be slave, the way it is shown here on screen. So these two machines, master and slave, would be having multiple services installed on them. Your master would be having Puppet installed, Jenkins installed, Git installed.
Yeah,
Um,
I have verified the services on command
Fast.
prompt, but
Yeah,
it was running. But now today, yesterday it was running, but now today when I opened the VM again, then it was that that command prompt was not coming only. I don't know
the
why.
command prompt was not coming. Um,
Yeah,
okay, can you
so
try it one more time?
okay, give me a minute. If I can share my screen, it will be easier.
Yeah, I can, but try it out once.
Okay.
Because if the problem is with VirtualBox, I really don't make it a point to fix things here on
Yeah.
VirtualBox's side. Okay.
Okay, so I have two things, VM master and VM slave. So do we need to
Yes.
clone the master?
See, if you're using OVA, you don't need to do any of the stuff that I'm talking of. Don't install
Okay.
anything, don't clone anything, don't worry about the network, don't worry about the host name and IP addresses. Don't worry about copying over the keys. Nothing of that stuff. I'm just doing it the crude way because I want you to know how this has been built, because it would make no sense to just tell you how Jenkins works on the browser and not knowing what happens behind the scenes,
Okay.
right?
So after this two master and slave is there in our system, then what we have to do? Because after that, we have to log into VM master or VM slave.
Both of the machines. Okay, if you're working on Jenkins, it would be your master box. So if you would like to see Jenkins like this on page, master would be the machine whose IP address you would be using. Okay, so for OVA guys, be happy that you don't need to do anything. You
Okay.
just need to open your browser and work.
Okay. So it's showing the status powered off. So we need to start that, right?
Yes. All right.
So
Just
when
try it out.
so when Yeah, yeah.
Mhm.
So when we start this, then because as you showed, we have option comes for like command prompt.
Mhm.
So that command prompt we have to set or how to install Jenkins, because already it was there. And I was trying to log in with the local host also, but I was
Mhm.
not able to log in with. It was showing some error.
Okay. The credentials for your OVA
Yeah, it
machines
is
are
the
Edureka
Edureka,
and Edureka. Right.
right?
Command prompt would already be there. Services are already installed for you. Don't need to touch anything. Just need to work on the services which are already there.
Yeah, I was not touching the services, but I tried to log in with localhost and giving the user Jenkins URL came, and when I tried to give user ID and password, but it was not getting logged in.
Okay,
It
so
was
the
saying,
user ID is Edureka and the password is Edureka at 123. How do I
okay,
know it? I've checked this file. I just scrolled it down. At the last page, you see there is a Jenkins credential for it. Okay. The URL for your Jenkins would be the IP address of your machine, of your VM. Okay. The IP address can be found by typing ifconfig. You type that IP address, not localhost. Localhost will not work. It is your VM. It is not your localhost. So it would work the same way I have typed in here on my browser. It is my IP address colon port number 8080.
yeah. So just now I logged in and logged into the VM master, and now Ubuntu desktop has come. So yesterday I was able to see the command prompt here, but today is only I have three four things like uh, Firefox and on the search your
Yeah,
computer Firefox and
it's fine.
look
You could get the terminal from there. You could go to the applications and look for terminal or simply type in Control Alt T. It will also bring up the terminal. Or you could move and type Control F1 and it will also give you the terminal. Whatever you prefer.
Control F1 I tried, but it's not giving.
Try Control Alt T. It will also give you the terminal.
Yeah, now it's showing Edureka at the test 01.
Cool. So that's your terminal. You could work on that.
Okay, and so we need to install like putty what you said, or we need.
No, you don't need to. I have also told you that people who are already working on Linux and Mac, they don't need to do anything with putty. You could simply type in sh and the commands would work for you. So
Okay,
sh space username @ your IP address should work. If you want to connect to that VM now from your host machine, you will have to install putty on your Windows outside, okay? Not on the VM.
so this setup is going to work, right? Means you don't have to
Yeah.
install anything, and with this only we are going to use.
Yes, if that makes you happy.
And one more thing, like if you do SSH username is our means it's my name, right?
The username which is present on that machine. So when you
That
use putty, the username would be the username that is set on your VM, which is Edureka, not your name.
okay. So we need to give Edureka only, right?
Yes. All right.
Yeah,
Is it
yeah,
all?
yeah, yeah, yeah.
Cool. Thank you. Next question here from Siddharth. Yes, Siddharth.
Yeah, Ashish, we were talking, right? So after the class, you would spend some time and help me get this stuff configured properly.
Um, this stuff, as in, can you please
Yeah,
set the
we were
context?
thinking that instead of using the OVA file you were earlier mentioning yesterday, you try to download your own server and then try to do it everything yourself.
Uh-huh.
So, and then there was a network connection. I had selected that adapter as host one
Only.
and yeah, host only, and in the advanced setting I had also done allow all.
Mm-hmm.
Uh, but still, when I am running that ifconfig file, it was not showing me the adapter 2 as Ethernet 2 and details were not coming.
Okay. You have
And
missed one step, buddy. The step
okay,
is to configure that new adapter. By default, your operating system will configure only the default one, which is ETH1, sorry, which is ETH0 pointing to
yeah,
adapter 1, right?
yes,
You have added another adapter called adapter 2, so we need to manually set it up in our operating system. The way you set it up, I've show this already. So you could open up a file
Hold on. Just hold on.
and
Give me a
see
second.
network interfaces. You could get the steps on internet as well. Add an adapter in Ubuntu, okay? So you have to
Okay.
add 2 more lines to this file,
Uh-huh.
okay? Line number 12 and line number 13. It looks exactly same like line number 9 and 10, only with the
Oh.
difference that ATH0 has changed to ATH1. Once you do that, okay, once you do that, you could type in if up. That means interface up ETH1. It will bring up your interface, and that's how you would
Oh.
be able to connect to this machine.
Okay,
And
okay. Can you
type in
just go back to that file? I will just copy that stuff.
you already have the file. You don't need to copy, right?
In interfaces, I have to just networks slash interfaces. I have to just go and add this auto ES1, right?
Yeah,
ES0 is already there.
ETH0 will be there. So you just copy ETH0 and iFace ETH0 and DHCP as it is, and change
Got it,
ETH0 to ETH1.
got it. Okay, got it. So now coming to the subsequent part of Git, what one thing which I missed when you were doing explaining about Git is if I proceed by this way, I will need two server installations, two servers, Ubuntu servers, one for master, one for slave. I'm assuming we will pass through this step because you have explained to me on the server when I generate the key. Can you just explain that one piece again for key for the client to be able to access the server through that key gen thing? I
Okay.
made my note.
Um,
I will go through the class, but just once quickly.
So this is a very generic thing. Whenever you want to authorize any user to connect to any other machine over SSH, okay, this is not specific to Git. It is for any system that works on SSH. So this client machine needs access to yet another machine. Okay. So what
Mhm.
do? Is we generate a key and we tell the other machine, that means the destination machine, that I want you to authorize this key always. So any user who is passing this private key should be authorized against the public key. So for generating the keys, you generate them using SH keygen. Okay, what it would do is it would create a hidden folder called .ssh and it will generate some keys for you. So if you cd to .ssh, there would be two keys generated. One would be ID RSA, which is a private key. You should never ever ever share it with anyone. Never.
Okay.
Okay.
Mhm.
Then there is IDRSA.pub, which you can share with any other person who wants to authorize you. So what I did, I simply copied the contents of IDRSA.pub onto the Git server. So
Uh-huh.
in bigger companies, what these people do is they generate keys for you. They don't ask you to generate the keys. They will generate the keys for you on your behalf. So your admin will share the key for you. He will say, hey buddy, this is your key and you should be logging in using this key only. Okay, so admin already knows your public key. He will take your public key and put it on any machine which he wants to give you access to. Make sense?
Got it.
So
Got it.
copy this key over. Either use copy paste or simply use SSH copy ID. That would also work. Okay, so either ways you
Mhm.
could do it. Git at the rate whatever your IP address is, and it should work.
Oh, okay. Got it.
Yep.
So just type that command once again. That copying the command. I'll take a screenshot of that command.
SSH copy ID minus I username at the rate some
Oh,
IP
IP
address.
address. Got it. Okay, I taken a screenshot. Done. Thanks. So let me just try this out, and I will let me just get back if there's any problem.
Yep. Thanks.
Okay.
Another question from Dinesh. Yes, Dinesh.
Hi, Ashish. Hi.
Hi.
Ashish, I'm still stuck at the VM thing, and I think probably I'll be repeating few of the questions which you just asked by a few of my other colleagues. So the
Okay.
only thing I would request that, it's a pretty good session we are having it, but we're all hungry to log in and start doing something. And there are some very basic things I'm again going to repeat it. So if you can just jot down some initial setup and how to go into the VM and start doing it, that will help. So unfortunately, I have to repeat everything to start my things going on. So I've got
Okay.
those
Hold on.
two OVA files, master and
Uh-huh.
slave, in front of me. Okay, you want me to
Okay.
hold on?
You,
And
you're
then, as you
working with
said,
VMs or you're working with
I've
OVAs?
got Windows 10. I've got Windows 10. I've got two files, OVA master and slave with me. And I can
Mm-hmm.
say power off, power off. And after
Mm-hmm.
that, do you want me to clone? I know all the services have started. and everything is there. But what is next? Where do I go?
Okay, cool. So there are two ways, okay? First way, I'll discuss later on. Second way is to use the OVA. That means the PDF that you see on screen, you're following that, correct?
No, I've got those
So,
two. I can see DevOps VM Master, DevOps VM Slave on my virtual box. So I'm up to
correct.
that already.
Right, for other people. So other people who would be using this PDF, they will be having two machines like Dinesh is talking. They would be having two machines. One is master, another one would be slave, right? From the OVA files, you have got it, right, Dinesh?
Yeah, I got it.
Right. So these two machines are already there, which are pre-installed by all the packages and services that we need during the demonstrations. Okay, if that is the case, you don't need to do any other stuff. You don't need to update anything. You don't need to install anything. You don't need to copy the keys over, nothing. Your machines are created and they are full-fledged ready. So you don't need to clone anything. All right. Only thing that you need to do is power them on. Just
How do we
power
do
them on.
that?
That's it. Double
How
click
do we do
on
that? Oh, double
double
click.
click on the machine or choose a machine and then click on the start at the top left.
Top left.
You see the start button? You could view the screen. I'm also sharing it. Or right click on it and then go to start.
No, there's no start on. It says start normal and things like that. So which one you want us to click?
Start normal.
Start
Normal
normal.
start.
Okay.
Yeah.
Okay. So both of them are double clicked it, and now it is in running state. And then what do we do?
Correct. Once they are in running state, you should be able to see the screen. Okay.
No,
That
that's the
screen would
problem.
be, yeah, it would come after a couple of seconds.
Achha, okay.
If the screen is not coming up, you could try double clicking on the icon and it should show you the screen the way it's showing it for me.
On the running,
Yeah.
you want me to double click?
Yes. Yeah.
It says Ubuntu, continue to wait or press S to skip mounting. Okay, something is coming up.
So it will get you a desktop version on which you can get to the terminal. Control Alt T is the command for getting the terminal on Ubuntu.
After this.
Yeah. After you get it, you
Okay.
log in and then you get the terminal.
Oh, there's no login coming. It's a kind of a browser with in between. It's completely black. Desktop version. Yeah, it says no DevOps VM running Oracle VM VirtualBox. Oh, okay. Okay, Edureka has come. So I'll just type Edureka, right?
Yeah.
Edureka, enter.
For people who want the PDF to be shared, you could log in your LMS, and there's a link for that. I'll show you where. Once you log in, the link should be available here. Edureka DevOps VM installation. Okay. Course content. That's the first option. When you click on it, there's an option for download. This is where you get the PDF from.
Okay,
Other
so I've got
links.
the blank.
Yeah.
Sorry.
Yeah, go
I've
on.
got the blank screen, and now what? There's nothing here. It's just a blank screen.
Try scrolling up and down. There should be there should be something.
There's no. Oh, okay. There are quite a few icons on the left-hand side.
Yes. So what you could do is you could zoom out the screen, take control of it, and then you could see stuff. So for command line, you could type in Control Alt T and get the command line.
Control Alt T. Yeah?
T. Yes, T.
Okay, I typed it. Something is coming. Oh yes, it did come. How do I scroll? There's no scrolling actually. That's the problem. There's no scrolling anywhere. Is there something shortcut for the scrolling?
No, there is no shortcut for that. But you could change your displays.
Oh, you mean that display is 640 by something so that it comes down?
You
And,
could change
okay,
it.
fine. I'll try that. The same thing we do for the slave and the prompt will come.
Yeah.
Okay, and then we can, whatever is written on the PDF to test things are running, that's all we need to do.
Exactly. And then you could directly start working with it without worrying about any installations.
Okay, you do the IP config on the master or the Jenkins?
See, it's on the machine. It's a Linux property. IP config is a utility that gives you details about your interfaces.
So the slave and master
both
will have the same IP address?
No, they should be having different IP address. Otherwise, they cannot.
Oh, so Jenkins is on master. Sorry. Yeah, that's helpful. Thank you very much.
You're welcome. Thank you. I'm moving to next question here from Nagendra. Yes, Nagendra, your question next.
Yeah, Ashish, I was just trying to download that .ova files. The file size is just continuously increasing. It's gone up till 269 MB now. So what's the actual file size of that OVA?
Yeah, it would be close to 700 or 800 MBs, I guess. I'm not sure, but
each file Okay.
Yes.
So each master and slave separately, it's 700 plus 700 MB.
Yeah. It could be more, but it would be minimum 700 MBs, I think. For other people who have downloaded, they must be able to give the exact size.
Okay, fine. If they expected, I'm okay. I was because a little bit wondering how long it will take. That's
Okay,
one
I'll give
question.
you an idea. It's 2.8 GB and 1.9 GB. Thanks, Siddharth. It's 2.8 GB
Okay.
for the master and 1.9 GB for the slave.
Okay, great. Thanks. I'll wait for that. Secondly, I have installed Oracle VM VirtualBox Manager. So the best way to configure is just use that OVA that you have guys have provided, or it's that's a much pretty faster mode, right?
It's faster mode. It will help you to start working right away. But just to answer your questions, that generally people wouldn't be more interested in getting spoon feeded. Okay, so that's the reason why I've
Yeah.
told you the other way. If you want to work the other way, you're welcome that way as well. Thank you so much, guys. I'll see you again next week with the next module. It would be module 3. We would be talking about Jenkins in details and see how the code flows from left to right. In case you have any feedback and want to suggest directly things to me, you can use this feedback form and suggest the things. I monitor the feedback personally. Okay. So thank you so much. I'll see you next week. Have a great week ahead. Thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!